Hello everyone. Welcome to Big Data Fest 2023. I'm Taras Klyoba, Big Data Competence Manager at SoftServe, and I am one of the organizers of this conference. This conference is organized by Big Data Community and SoftServe Inc. company, and our main goal is previewing of future of data engineering. And this is our first Big Data conference, but we plan to hold this conference every year. And we hope, will be a nice place where people interested in big data can get together, learn new things, and discover what's new in the field. And please let me introduce our program committee. As I already told, I'm Taras Klyoba, and also I was part of this program committee. Also, we had John from AWS, Anil from Google, Anil from Microsoft, and Anil from Google Cloud. And we decided to bring together representatives from Microsoft, AWS, and Google, because we aim to ensure a transparent session selection process for everyone. And I want to express my gratitude to all these folks who contributed to these events, and especially to our program committee. And some statistics, as we Big Data Conference, we also have some nice numbers, and we received 61 submitted topics from 43 different speakers, and we selected just 11 topics for our conference. And also today, in our first day of the conference, we'll have panel discussion with Rodion Myronov, Director of Big Data and Analytics at SoftServe, conducted also with 3 another top experts in the field. And what we also want to add is that today and tomorrow, we will have great speakers from some big and small companies, for example, from AWS, from Microsoft, from SoftServe, from Cloudera, or from Colse, and from another companies. And I personally cannot wait to hear their presentations. And also, we were supported by our partner communities, by PowerShell Portugal, IT Pro Portugal, Cloudview, Power BI community, Data Community of Portugal, Pact Company, Data Engineering Latam, and also by Data Community Poland. And what is really exciting that we have more than 600 registrations for our conference, and we have people from more than 50 countries around the world. And this is almost all from my side, but really important that our conference is totally free, but you have option to contribute by donation to the OpenAI charity fund founded by SoftServe. And your donations will be used to directly support purchase of a special medical equipment for hospitals in Ukraine. And I'm personally will really appreciate any contribution you will take, and also Ukrainian hospitals and people from Ukraine will be really thankful to you. And we hope that you will have a fantastic time at this conference. And our first speaker is Taras Bachynskyi. He is Vice President of Technology at SoftServe, and he will share insights on industrial metaverse and digital twins. And Taras, stage is yours. We are excited to hear from you.
Hello, everyone. I'm glad to be here. Give me just 1 second. I'm going to start the screen sharing.
Yes, sure. How are you, Taras?
Everything goes well. It's a sunny morning here in Austin. So unfortunately, I don't know how many people we have, from which location we have the people who are joining this conference, but I hope that everything is going well on your end, guys. So here we go. I see my slide deck. Just give me one more moment. Okay. Can you see my screen?
Yes, everything fine. And then I wish you luck, Taras, and the stage is yours.
Yeah, thank you, Taras. So today we will be talking about the industrial metaverse. Actually, I can probably even start from the previous screen so you better understand the topic. It's a new big trend that we observe right now, and not only observe, but we heavily invest our efforts. We have pretty good opportunities in this regard, and I will be glad to share a little bit more insights about what is this industrial metaverse is about and how we're leveraging our skills and expertise in this regard. So we will be talking about the architecture. So basically, here is an agenda. It's pretty simple. Basically, I was driving the big data and analytics direction in SoftServe for some time. Now my focus is towards digital twin industrial metaverse. We have a lot of the tracks with NVIDIA. It's both in the industrial space and the innovations in terms of the generative AI and some other cool stuff that's happening around AI. And then also, I'm driving Web3 and the blockchain practice here at SoftServe, but today we will be focusing on the first two topics, and that's digital twin industrial metaverse. So I was about to show you, like for those who are not familiar with the industrial metaverse, I was about to show you like what it means to have this kind of this presentation in the metaverse, but unfortunately it will be too much screen switching. So like we have a really kind of the game that you can go, like the game-like experience when you can go to in the metaverse and see different presentations. I will skip this one just to give you the better idea what this metaverse is about. And the concept itself was first introduced for the consumer market. Let's say if you're talking about retail, banking, like when you can provide, like the banks, for example, or the retailers can provide the services in the metaverse. You have the consumers that can join, let's say, go to the virtual stores, make some purchases, and so on. So this is the concept of the metaverse. Once again, more emphasis on their consumer metaverse. Now, when we are talking about the industrial metaverse, I would like to show you one video to explain the possibilities of the technologies and how exactly this can be leveraged. I will explain moving forward. But let me just share one video file with you to play the play this. Can you see the video? Can someone confirm that you can see this?
Yes.
Okay, perfect. So this is an example of the, I would say, industrial metaverse, one of the application scenarios, because you can get, like we will discuss several of those. But here it's specifically, it's a platform, Omniverse, built by NVIDIA, where you can simulate, like you have not, this is not only 3D rendering of the equipment. So you can also simulate the physics. And for example, when this forklift is about to hit some obstacle like this, you can calculate all of the physics and what would happen in the real life if these things are happening in real, right? So, for example, if it's running on this speed and hitting these boxes, what will happen with these boxes? So there is kind of the geometry, physics, and other stuff that can be calculated in the simulations. So it's just give you the better idea when we are talking about the industrial metaverse, what the level of the fidelity we can get. Okay, so let me now switch back to the presentation. And then, okay, I think that it's someone else need to just, okay, yeah, I see my slides. So give me just one more second. Yes, here we go. So basically, in terms of their, if you're talking about industrial metaverse and the digital twins, I will explain you some application scenarios at the beginning, because like why this important for some of you guys is because like for big data experts, it can be one of the workloads or one of the consuming workloads that you are potentially need to handle. Let's say if you in the variant you need to have the data lake and some other, maybe some data stream that you need to leverage in order to build this digital twin industrial metaverse. This is just one of the building blocks. And from another point of view, I think I would like to also raise some curiosity to this topic, so at least you will be aware that what is happening in the industry, that there is this kind of project as well. And basically, like in terms of the key application scenarios, so let's go from left to right. Prescribing, it's basically a number of the different models that is typically built by their data scientists or the engineers. Let's say when you can predict or simulate a certain behavior of the process. For instance, if you're talking about the production process, like you can build a model when you can simulate what would happen if you are about to replace one of their cells or the robots in the production line, so it can simulate the overall throughput, and then let's say the end user can really just use this simulation model to make a decision how to improve the production line. But basically, it's a number of the different models, AI-driven models or data-driven models. Actually, it can be physics-based models, can be process-level models that actually you can run and simulate a different behavior, run what if scenarios, or run some optimization algorithms. Then another big area, it's another big topic, it's 3D visualization for many of our customers, and actually this is for the industry. It's important, like if it's like the complex industrial environment, they use 3D and the immersive experience to just deliver the information, right? So in other words, you can stream all of this data points, sensor data, and things like this fit into their 3D model, and then you can have a really super comprehensive user experience when the end users can navigate, not only one user, but potentially team can share all of the insights and navigate through the 3D environment. So there are certain examples. I don't think that I will be covering this in the very deeply today, but just to give you an idea that this is really important for certain business areas. Then collaboration is another application scenario. For example, when you are the part of the design team and you are building the car, if there is a lot of their collaboration efforts that you can, let's say, originally you're spending a lot of the efforts when the teams need to travel or have the, let's say, joint meetings. In the collaborative way, it means that you can create the body of the car, you can simulate like the behavior of the light, you can also integrate the behavior of their some PLC components. So in other words, you are leveraging this 3D environment to tie everything together, create the photorealistic rendering of the car, but also simulate some other, let's say, components that it's really hard and time consuming when it's building in real, like just using physical environment. And of course, there are some cases when the customers like can leverage this 3D environment to set up the configuration for the same car or things like this, right? I hope it makes sense. And then autonomy, it's another important topic, because today the level of the automation is sometimes really, I'm impressed when I see how robot can operate in the facilities, but basically in the very end, they you start this journey from building these robots and making the right decisions in the 3D environment in terms of how to exactly implement this or that feature of the robot, how to make sure that the robot can recognize obstacles and things like this. This is kind of the four key application scenarios, just to give you the good idea what is this industrial metaverse and digital twins, the key focus areas are about. And then if we're talking about the industrial metaverse, first of all, the focus was on the collaboration. This is exactly what metaverse introduces into display, but now many people are using this term just to explain the overall capabilities like the digital twin industrial metaverse. So in certain cases, we really need to be aware that there are some kind of the ambiguity, and every time it's required to have the conversation with the team, with the customer, to make sure that they have the same understanding of these topics. So just to give you a few examples how it looks like in the real life. For example, like the oil and gas rig. If you have a number of those rigs, then basically like, well, this is not the perfect picture because like today the production process for the oil and gas is a little bit different. But the point is that you can build the process that can simulate and provide a recommendation what will be the best configuration of this equipment that can lead to the, let's say, reduce energy consumption and increase the oil production. So this is purely kind of the algorithms or model that you are running. Sometimes there is no even any 3D visualization in this specific case. The case with the car, I just provided you the brief overview when we discussed in the previous slide. And robotic simulations. So this is an example of the vertical farm. It's like kind of the container when you are growing some plants, and then you can simulate robots to make a decision how to build these robots that can be effective in this kind of the tasks to plant all of this, plant the plants inside this container, right? So here is a visualization and to explain you this first case about the oil and gas rig, right? So configuration of the equipment, and then depending on what configuration you can take, it can lead to the different outcome in terms of the power consumption and how you are going to separate, let's say, water, gas, oil, right? So in other words, some controllable metrics, all the controllable outcome. In terms of the what does the a few highlights about these two topics for the industrial metaverse and digital twin. So in many cases, it's custom solutions. And you need to build, it's usually this journey starts from building the technology foundation, and big data played a very important role in there, because like without this data foundation, it's really hard to implement anything. You need to have the data in place in order to even start this journey, right? But in overall, it's, let's say if you have two customers from the same industry and with the same even challenges, we still the big chance that it will be kind of different, two different solutions. There might be some reusability of the certain components, but in the overall, it's really very custom development and implementation. So it's usually like we leverage certain platforms and the SDKs to implement this simulation layer, right? But in the overall, it's every time we are building a lot from scratch, and this is the specifics of this industry. And then from the challenges perspective, I believe that once again, this is absolutely a relatively new area, and in many cases, our like this terms understanding of this domain is something that is required to reinforcement of this around all of these topics every time I have the conversation with the customers. So that's why we usually start with a kind of the consulting bit, and then just to identify the potential opportunities and make sure that we align in terms of the terminology and so on. But another big challenge is because like even we have some alignment and understand what we need to do, like what the use cases are important for the customers. It's a huge effort to really let's say, once we dive into any technology topic, there is certain kind of the complexity, and even internally in the team, it's sometimes super hard to make sure that everyone understands it the same way and understand what sort of the architectural drivers are important to consider for this entire projects. So there are certain technology, certain level of the complexity that it's important to handle throughout the entire journey. Okay. Just to briefly explain you some motivation why these customers are looking to this sort of the solutions. I'm talking about the industrial metaverse. For example, for the Mercedes, when they are let's say they currently are producing A and B class models in one of the factories near Stuttgart. And their goal is to really switch this entire plant to electric vehicle productions. So for them, it means like if they do this right now, they need to stop production of this A and B class and start reshaping the entire factory to build this like the new assembly lines for electric vehicles. And this required to stopping production of this A and B model. It's a huge cut in the revenue. So it's I don't know, it might be not millions, it's maybe $100 million or even more. And that's why they are investing into the build this entire IT solution when they can run everything, kind of build this entire plant in the simulations, in the virtual environment. And then after they make all of the decisions and ensure that it works, then they can just stop the production of this A and B class, change the configuration of the plant, and then start production of the electric vehicle. So in other words, they are leveraging IT. I know that they're working with the Microsoft. They're building a lot in the Azure platform, a lot of the enabling capabilities for these projects. And of course, they are leveraging other technologies. Maybe we'll be touching this a little bit later to implement this simulations. Another example is process manufacturing. So we have the cases when our customers are really looking for the automation of the entire factory, just because it's because of the lack of the expertise that they can hire on the market. This is can be one of the motivations. Another one is, of course, to get to the certain level of the efficiency when the production lines can be self-optimized. But it also starts with the data exercise. We need to build their entire infrastructure, right, that can be leveraged to all of the automation scenarios. So basically, like, you need to let's say design the infrastructure that supports different kind of the workloads upfront. So in other words, like invest into this technology foundation once, and then build and then leverage all of this automation capabilities for the different steps in the entire value chain, from their factory design to the execution and whatever, still leveraging the same technology foundation. For the energy, oil and gas, it's there is a lot of the physical simulations. I probably already mentioned for some of them in the previous example, but in the very end, you have this pretty complex, like it's a electric submersible pumps. It's one of the most important topic for in the oil and gas. There is a lot of their challenges associated with the let's say maintaining all of this equipment. So this is exactly where our customers also leveraging the digital twins and industrial metaverse to perform the different kind of the simulations and optimizations and non-optimizations. For the utilities, it's also a very interesting topic, because like today, or actually traditionally, you have this fossil fuel generators, like using coal, for instance, and then you have the consumer, and like decade ago, it was let's say in most of the cases, it's you have kind of the rules that you can set up or like increase the production depending on what time during the day it is, because like you know that like the utilities know the overall consumption during the day, and they can just kind of set up some rules how to what will be the right configuration of this entire environment for the generation and transmission, and then there is no much that they are doing in terms of let's say when they are maintaining the overall workload inside in the grid, for instance, right? Today, because we have a lot of the electric vehicles, we have many consumers that using solar panels. Let's say like the private householders, they have the solar panels, and it's also can impact the overall consumption of their energy, right? And also their production of the energy. Now we have more and more. We have a trend when their production is moving towards the green energy, like the solar panels, wind turbines. I mean, solar energy, wind energy, whatever. And this source of energy is really depends on the weather conditions and some other areas. So now the entire industry is moving from the kind of the deterministic way of managing this infrastructure to the probabilistic way, when it's important to have their proper model in place that can predict, optimize, and simulate different scenarios. So it's a big move that is happening right now, and IT technology is intended to create the new capabilities that can be used to make this entire energy management much more efficient. So basically, like I can summarize this the story about the digital twin in terms of that we have number of models. Usually they are knowledge-based models, and then certain application scenarios from the monitoring, analyzing, predicting to the prescribing stages when you simulate and run some optimization algorithms, and then adapting when we were talking about this training of the robots and whatever. So there's a lot of the ways how you can leverage these models. What it means from the technology perspective. So it's a kind of the reference architecture of the typical digital twin, and I would say industrial metaverse digital twin solutions. So you can see that you have a pretty standard setup on the left, right, when you have all of this ingestions, data processing pipeline, or you can leverage data virtualization. Basically, you need to have both batch and stream processing. Then basically you need to have their, let's say, some middleware that can support the digital twin in terms of the data storage, and they're building this semantic data model, right, of all of the entities important for you to maintain when you are running digital twin workloads. And the complexity is that you usually deal with the many different entities, and it's important to kind of reflect all of this underlying ontology in this digital twin layer, when you can design this workloads in the way that you can really get some bits of the information. You can run the simulation for that this or that scenarios. You can kind of have the data points. You have their models and other algorithms that you can leverage to simulate the behavior of the real objects. And then you have this mediation, like it's basically you can handle all of this complexity by pre-building some specific workloads, and basically you can just use the API calls right? And in case you need to just get the future state of this or that component, or when you need to run the simulations of optimization. So we have this digital twin mediator that can handle this underlying complexity and implement in the ways that you can really kind of combine the different requests to the data storage with the running the simulation, and then you're returning data to the UI, sort of, right? And of course, from the data standpoint, it's important to leverage all of their best practices in terms of the governance as well. So here is, and now when we're talking about the Omniverse, I just decided to, it's a little bit different kind of the visual. I was going to build this the same way. I didn't have much time, but I think you will find the similarities with this previous diagram. Over here, we also have this ingestion and processing layer, right? We have the data storage, and then the example that I mentioned previously with this forklift, right? NVIDIA Omniverse, this is the technology that is being used. But basically, this NVIDIA Omniverse, it's a, I would say it's an entire platform with many different SDKs that you can use to build this custom workloads. So in other words, this whole idea is based on the USD format, which was originally built for, let's say, co-simulating or co-rendering of the different, let's say, visuals, 3D models to build the animation specifically to create when you're creating the cartoons, or maybe in the movies industry as well. But now NVIDIA is leveraging the same approach, like collecting all of these bits informations in the nucleus, which is the core of the Omniverse, and providing a different SDK that you can use to run this workloads, to let's say collect the data and maybe build their this data model, data points in the real time in the nucleus, given the possibility to the other components of the Omniverse to just use this data and render this and show to the end consumer. Okay, and then here is another example. It's a reference architecture when we are talking about the telco industry. There is a lot of the libraries already in the market, that can be leveraged to simulate the behavior of the network, but you still need to have a pretty good data foundation for this. So it's, I would say that it's usually like on all of these diagrams, you have the left part, which is a data foundation and data lake, data warehouse. And then on the right, it's all of this consumption and like the user interface. If we're just touching this briefly. And then for the energy management, it's a pretty similar way how you can handle this workload. So basically, if you would like to understand better the consumption of the energy in this or that enterprise, in the manufacturing or some other industrial areas, you are collecting the data. You need to ensure that the data model is flexible enough to run these different workloads. Then you have a certain specialized tool that you can use and run. Like there's something in the bottom. It's a number of the analytical reports or the very specific models that you can run on top in order to provide the better idea how to, let's say, optimize their energy consumption for this or that enterprise. So basically, that's it from my side. I hope it was helpful and insightful for you.
Yes, Taras, it was really nice and interesting presentation. Thank you. And we have a few questions from our audience. First question is from Olga Nazarenko. She is our colleague, and the question she has really interesting question. Yes, because you've shown some cases where we use digital twins and the industrial metaverse for some VR applications and environment. But maybe you know some case studies where we combine AR, augmented reality applications, with concept of metaverse.
Well, I think it's VR itself is a part of, like, you, in order to build industrial any metaverse, consumer or industrial metaverse, the VR is one of the building blocks, right? So in other words, in some cases we just use VR to really augment the real environment. For instance, if you're wearing some glasses, and then it can add some another kind of the bits and the information that are available somewhere in the whatever in the system, and then it gives you. And then when you're pointing, you look to the some of the equipment, it can just get the information from there. This information expose you in the VR, right? So this kind of the capabilities is something that is foundational things for their industrial metaverse, for the metaverse itself. And well, I provided just one of the examples. This is many way how you can leverage XR VR in there, right? But I would say this is rather foundational aspect of the metaverse that is being the part of their, like, when we're building solutions, we usually have technologies involved, XR VR technologies involved into this in the solutions.
Yes, I see. Thank you. And one additional question from Hanna Kurashova, and maybe we can extend slightly this question, which we see on our screen. You also mentioned that currently we see like transformation from this deterministic approach to probabilistic approach. Yes, and here we have also a question from our audience. What currently more popular? Yes, replication of reality into metaverse, or creating or pure digital products? And maybe my question, by extending this, what you see currently more often, that companies start already from probabilistic approach, or first of all they need to collect some data and go from deterministic approach first?
For me, it sounds actually it's two different questions, right? Maybe I'm wrong, but it looks like that the question number one is about replicating the reality or building digital products, like you're starting with just creating the virtual asset. This is the first question, right? And I would say I really don't have any statistics, because it really depends on the industry and on the very specific case. So it's hard to tell which one is the most popular, which one is not. But it's really, let's say, in some cases, yes, we are starting absolutely like there is nothing yet. We're just starting with the virtual design, the simulations, right? Build this in the virtual environment and then go and do this in the physical environment. And sometimes it's the vice versa. You start with the physical environment to understand some phenomena in there, and then build models around this, and then you can leverage this models to handle this complexity, right? When you need to make a decision, it's hard for you to understand all of this, let's say, relationships with these entities and so on. You would rather go and use this model specifically for the business, right? That reflects the behavior of the physical environment. So I would say this is kind of both are important. It's really hard to say which one is most important, which is one is less. And to answer the question that how I understand this from Anna, right? And to your point about the deterministic and the probabilistic, it's currently like, I believe that technology is already in place. Like we have all of the capabilities. We don't need to create any new technologies. The challenge is to really build models and environment that can be really very accurate, that then you can use to prescribe business what really is important to do in this or that models when you're talking about the energy management, right? So it's more, I would say, the challenge is to really, let's say, build this solutions, technical solution for a very specific case and ensure the precision and the quality of this or that solution.
Yes, I see. Okay, Taras, thank you, and hope that soon we'll have a chance to meet in person.
Yes, likewise. Thank you for the opportunity to speaking on this event. Good.
Okay, thank you. Thank you, Taras. Thank you, everyone, for questions. And I invite you all be more active, add more questions in our chats, and we will moderate these questions and address them to our speakers. And currently, I want to invite our next speaker, and it's really a pleasure for me and honor to invite James Serra from Microsoft, big data evangelist and data warehouse evangelist with topic data lake, data mesh, and data fabric. And maybe yesterday you also saw some new announcement from Microsoft, and maybe you can slightly tell something to us, to our audience, about these new capabilities which Microsoft provide for this market of data analytics and big data also. James, happy to see you, and the stage is yours.
Yeah, thanks. I'll jump to my slide deck. And I'm sure a lot of you have, well, hopefully some of you had seen the announcement yesterday at Microsoft Build on a new product, more of an enhancement to Power BI called Microsoft Fabric. And I'll touch on that maybe a little bit as we go along.
Yes.
So,
sorry for interrupting. All my LinkedIn feed currently in new articles, in new reviews of these new features. Really exciting news for everyone.
Yeah, it's really exciting. I'll have a blog that will come out in about an hour and 15 minutes to give you an overview of what Fabric is, to kind of level set your understanding of it. And then obviously we're going to do a lot more with presentations and whatnot. And I already have some presentations ready to go for in the future to dig a little bit more into Fabric. But it does actually apply to the conversation today at certain points when we talk about the architectures. And so I'll drop a little bit of Fabric knowledge in there to help you understand where it fits in with this particular architecture.
Yes, I see. Please proceed. Stage is yours.
Yeah, great. So James Serra, I'm my official title industry advisor in Microsoft, and in a group we have called Federal Civilian, which deals with governments. And I've been at Microsoft 9 years, and this is the short background of my long history of doing this, 35 years. And this topic has come along when I talk about presenting on data warehouses, data fabric, data mesh, data lakehouse. That's a conversation I have frequently with customers, usually 2 or 3 a week. I'm presenting something very similar to them because there's a lot of confusion of what all these architectures are. And the customers, they want to build a data solution. They want to gather data. They want to get insights to it. They want to make better business decisions. And they're very confused on which approach to take. And so I created this deck probably a couple of years ago. And I'm also expanding on the deck in a book that some of the chapters are out now that'll go much more detail. But hopefully this will give you a high level understanding of the 4 architectures here. So I'm going to have a couple of slides on warehouse and lake. I'm assuming most of you know a little bit about what those are. And then we'll dive into the modern data warehouse, data fabric, data lakehouse, and data mesh. And feel free to put your questions in there, and I'll pause at times to answer any questions you may have. I have to say these are my opinions, not that of Microsoft. So there is there's really not an official version of the truth that Microsoft has for all these architectures. It's left to everybody's opinion within Microsoft. Now, there is a lot of commonality when I talk about these architectures. Most people at Microsoft have similar opinions on there, but there's no official word from Microsoft on there. So if anything I'm saying here, please don't go and say, oh, this is what Microsoft said. You can say, James Serra, Microsoft said this, but it's not the set in stone Microsoft view of things. And it's also challenging because it changes all the time. This slide I've had probably for 15 years when I've talked to people about why I have a data warehouse in there. And so hopefully most of you know why you have a data warehouse. I kept this slide in here though, because there's confusion when it comes to, do we still copy the data from the source system? And some of these architectures make it seem like you don't have to, but the reality is you do. And the big reasons you're going to copy it is listed here. One of them being the stress on a production system. You don't want to have these long-running queries and reports on a source system when people are trying to do updates and deletes and inserts on there. And so you'll create a data, you copy the data and create a warehouse for it. Now, we'll get into how many copies do you need, and is there a way to reduce it? And some of the new architectures are doing that, but in every case, you're always going to want to copy the source data. And there's a lot of different ways of doing that, but it all comes down to the priority is not interfering with the people that are using the source systems. And then we have what is a data lake and why use one. And it's, I tell customers it's just a glorified file folder on there. And nearly every customer that I deal with create data lakes on there. If they're going to build a solution in the cloud, they're going to have a data lake on there. And the big reasons, top 5 reasons for a data lake are listed here. There's many more that I can get into. The ones that I really like to stress with customers is schema on read, meaning I can just copy files in there just like I have with my folder on my laptop. I don't do any upfront work, as opposed to schema on write with a relational data warehouse where you have to go create the database and the table and the fields and write the ETL, and you do a lot of work to get it in there. And that could be troublesome sometimes if a customer, and I had this when I was a DBA for many years, they want you to put this data in the relational data warehouse, you do all that work, and then they come back and say, well, actually this data is not helpful on that. Now with the data lake, you can put the data in the data lake very quickly and run queries against that with some of the, especially with some of the new technology, to quickly explore it and see if it's got value. And then maybe after that, you'll copy it to a data warehouse, or maybe that'll be it because you just needed to run a query report runs. One of the probably the biggest reasons too with a data lake is if I have that relational data warehouse, I usually have a maintenance window, and at night I kick everybody off. I have these staging tables, I load data in there. I run the compute to clean all this data, cross my fingers and hope it ends in the maintenance window so people the next morning can use that data, because I'll copy it then into production in there. So customers say, look, we don't want a maintenance window in there. So this is where a data lake can come into play. Think of it as taking all of those staging tables that are in the relational data warehouse and putting it in those in the data lake instead. And so outside the relational data warehouse, you copy the data into a data lake and you're cleaning there. So a data lake is just storage, and you have options of compute that you want to put up there. And many times they'll be cheaper than what the relational data warehouse compute is on there. So I can do all of that outside of it. If I want to spend more money, I can put more compute. It's unlimited in the cloud. And therefore I get rid of the maintenance window. I'm not interfering with the people who are using the data warehouse. And when this transformation is all done, maybe there's a couple minute maintenance window to load the data in there, but it's already been cleaned and aggregated and organized in a way that's quickly put into the production tables in there. So that's another great reason to have a data lake. And there's tons of reasons on there, but the data lake and the data warehouse are in the past have been frequently put together and in the data architecture. And so you have at a high level, the best of both worlds in there. You can think of the data lake as a staging and prep area, and the data warehouse as that serving layer that also has the security and compliance on there. And this gets into the reasons why you still want to have a data warehouse are things like the security. A data lake doesn't have row level security or column level security. So sometimes customers will do the staging and prepping in a data lake, but only have the end users access to data warehouse because they want to do row level security. Other reasons could be it's faster in the data warehouse when you do queries because of the technology. It supports higher concurrency. The customers may be familiar with the data warehouse and it's a lot easier for them, because in the end you want to do self-service BI. So you want to give them an option to make it really easy for them. And so you can think of separating them out with these different functionality on here. Now, this comes into play when you look at the first type of architecture and call it what I call the modern data warehouse. And I break it out into 5 steps. Most architects will break it out into 5 steps. Maybe they call them something different. This is where I do a lot of whiteboarding with customers in there, because every use case with the customer is different. So the architecture is probably going to look different. And so I'll go through with them and I'll ask them a lot of questions, do discovery, and then come up with a high level architecture. And then at the end, I'll start putting products on the architecture, which are shown in green here if you're using Azure. And that, again, depends a lot on the answers to questions I get in them. If they're Microsoft Azure users already, probably go with just that. If they say, well, we want to use Databricks or Informatica, that could just be applied easily into the architecture in there. And so the whole idea is you're going to start out ingesting the data from various different sources, and you're going to land it in the data lake. And you can use a product like Azure Data Factory for that, or now Microsoft Fabric. And each section that I go through here could be broken out into a long conversation, because if you look at just ingesting the data, a lot of it depends on the size and the speed and the type of the data and the pipeline you have between the source and the destination. And do you want to do full updates or incremental updates and whatnot? But to keep it brief, you're going to ingest, for this conversation, you're going to ingest the data. You're going to land it into a data lake. And then in Microsoft world, this would be Data Lake Store Gen 2. And that data lake has different layers in there. And the data comes over as is from the source system into a raw layer. And that may be enough for the data science person who I show in a hat. I always have data scientists, people with hats for some reason. And that they could be, that's all I want is the raw data, and they're good to go. So in a matter of minutes, if not seconds, they can start utilizing the data from the source systems. And for other people, though, you're going to need to do more with that data. The first will be to clean the data on there. So you can use technology such as Azure Data Factory data flows, or Databricks, or Synapse, or Data Fabric now, or Microsoft Fabric now, to take that data from the raw, clean it, and land it back into the data lake into a clean zone. That still may not be enough for end users to make sense of that data. So you may take another step where you take that data and you join it. You could aggregate it. You can create a star schema and put it in the presentation layer. And if you're familiar with Databricks and their medallion architecture, they have the bronze, silver, gold, same thing. I just make it a little more descriptive. You can also have a sandbox area. Maybe the data scientist wants a copy of the data so they can do all sorts of stuff with it. And you can easily do that within the data lake. And this gets into data lake design, which could be a long conversation, because you want to make sure you design it in a way that's going to be able to ingest data no matter where it comes from and the size or the speed of it. And then you talk about folder structure in there, and you want to break it out differently for performance reasons or security reasons. You just don't want to dump all millions of files in one folder in there. So you think through the data lake design. So this comes up with a lot, and this also gets into governance too, because you want to use a product that's a data catalog, something like Purview, that's going to go and tell you everything that's in the data lake. And then end users or somebody in IT who's going to put data in the data lake should go to the data catalog first to see if it already exists, so they're not duplicating effort on that. And that's the great thing about having a data catalog in there. And it could scan everything in there, your source systems, data lake. You can look at all the data factory jobs you have. And so you have the ability to track lineage. And so that becomes a big advantage. And governance, I don't think customers do enough with that. So really spend a lot of time up front to think through how are you going to govern this. The last thing you want is to put data in there that's sensitive information that somebody's going to see who shouldn't see it. So you get the data in presentation. Now, that still may not be enough for the end users to make sense of it. And this is where, and this is changing, but this is in this modern data warehouse, which has been around for like the last 10 years, is where you copy that data into a relational database management system, something like a Synapse dedicated pool. And that data then is schema on write. So you're doing upfront work. You land it in there. It could be in third normal form. You could also then copy in the star schema. And you've done a lot of upfront work. IT's done a lot of upfront work to make step 5, where the end user can use a product like Power BI and easily visualize that data. They can go to a workspace and start dragging fields and create those dashboards on there and do true self-service BI without having to understand how the tables are all joined on there. So IT's done the work to create multiple copies of the data to make it easier for the end user. So this is where the trade-off comes in. More copies of the data means more expense, more ETL, but the benefit is the data is in a way that the end user can easily make sense of it and create reports. And that's where we've progressed. And the tools that are coming along to change this, but this is the modern data warehouse that most customers have done the last half dozen to dozen years on here and are still going to do. But this is where we'll get into the next couple architectures that are starting to change. Okay, so let's jump into the next architecture, the 2 of the 4 of them. This is where what I call the data fabric on here. Now, this is where somewhat diverge from what others may call the data fabric on here. I view the data fabric as taking that modern data warehouse and its evolution of adding more features to be able to ingest more data. And to do that, you need to add additional features and functionality to that modern data warehouse. So this has become popular over the last couple of years, is to do a lot more with security, access, and policies, to have that metadata catalog like Purview, to do lineage, to do some master data management in there. Maybe get into virtualization, adding in real-time processing, streaming of data from, say, Twitter feeds on there. Maybe you create APIs to access all the data instead of having connection strings in there. And then maybe you even build out the data fabric in building blocks so people can reuse parts of that data fabric without, if they don't have the need of a data fabric. For instance, a common, I'll see customers create some ingestion piece, and other people in the orgs will say, well, I don't need your data fabric, but I really love that ingestion piece in there. And if you build it in a generic way, they can have that piece on there. And that's where we get into a data fabric. Where it diverges from others, and what I call the intelligent data fabric, is they start adding knowledge graphs to this, and the ability to have automated tools that will go out and find your data and ingest it automatically and catalog it automatically. But I haven't seen any tools yet that do that. So that's why I don't go that far. I think that's a good way path we're going down, and hopefully we'll get that intelligent data fabric, and maybe with ChatGPT it makes things easier. But right now, I just call it the basic data fabric without a lot of those advanced tools that are really just coming into the market. Okay, so that is data fabric. Now we get into, and this is where Microsoft Fabric comes into play. A 31-minute history lesson in here is we started in the 80s with the data warehouse. For those of you as old as me, you may remember things like Teradata and then later Netezza, which are still around. And the data warehouse back then was for big data, which was like a terabyte, had everything encompassing what you would need encompassing in the software in there. So it was a relational database. It would have ETL tools built in, reporting tools built in. And then you maybe create the data warehouse and then subsets of the data warehouse and data marts on that. And that was very popular. And I got in discussions with people, the Kimball or Inman method of building out data warehouses in there. So that worked great. There's still a lot of data warehouses around like that. You could still argue that maybe that's a good solution for a limited set of data. But generally, we've gotten away from that. And in the late 2000s came around the data lake, which was hyped very much, and it was what I say, this land of unicorns and rainbows, that you just put all your data in a data lake and you don't need relational data warehouses anymore, and it will all come out magically cleaned and easy to access. And that failed miserably. I had customers that I personally had conversations with and meetings with who went down this path of, we'll put everything in data lake and get rid of our relational data warehouses in there, and it just didn't work. And they came back and said, yeah, that data lake is we can't have it do everything in there. And so this is where the data lake concept still stayed around, but it wasn't the be all do all in there. There was a subset of features that people started to use that I talked about before, with a lot of mostly focus on the cleaning and transformation of the data. So we got it to the modern data warehouse that I just went over. And now what's come out about 3 years ago is data lakehouse. It's a combination of the data lake and the data warehouse, data lakehouse, a cute term. And the idea was to go back to the idea was, we can go without a relational data warehouse. We can just use a data lake. And you should be saying, well, wait a minute, you just said that failed miserably. What's different? And what's different now compared to the first data lake is what's called Delta Lake. And Delta Lake is this software layer that is put on top of a data lake to give it additional features that are what we'll call it relational data warehouse like. Things like ACID transactions and some stuff you don't even find in a relational data warehouse, like versioning of the data. It unifies streaming and batch. It has schema enforcement, so you don't drop a file in a folder that is way different with schema and blows up your ETL. Like Delta Lake can prevent that from happening. Probably the biggest reason is it supports commands, SQL commands like delete, update, and merge, which don't exist in a data lake. There's a lot of work you got to do to update a rows in a data lake. Essentially, you ingest the whole file into memory, you make the change, and you write it back out. And that could be very time consuming, especially for large files, where Delta Lake, I won't go into the specifics, but is very performant when it uses those commands. So you can do that modification of the tables in there. So this opens up a whole other world of doing everything within a Delta Lake and not having to put it into a relational data warehouse in there to do a lot of the updating on there, or performance improvements. Now with Delta Lake, they have a lot of those performance improvements, things called like Z order. And so you can get really good performance on that data that you can't get against a data lake. And the great thing about Delta Lake is it's very easy to use it in there. If you're using Spark, on the right-hand side, you'll see this format commands. It's a matter of just changing it to say, instead of writing out in the Parquet or CSV, I'm going to write it out to Delta. And behind the scenes, it stores in a Parquet and it splits the file up and has sort of a log file with it, which means products need to know how to use a Delta Lake, which just about everything does now. So very easily you can have this functionality that enlisted here with the Databricks, their bronze, silver, and gold, is the ability to then have all this functionality and put whatever compute you want on top of that and not have to use a relational data warehouse in there. And so the use cases for this is it really solves for problems when you have both the data lake and a relational data warehouse. Is one is keeping them consistent. If your ETL has a bug and doesn't run, now you have two copies of the data that are not the same. Even if the ETL runs, the data warehouse is going to be older on that. So that could be a problem with inconsistency if people are going against one or the other on that. A lot of times the ML AI type of products don't work well or don't work at all against a relational storage in there, but they will work much better against file format and files in folders in there. And so that's where the data scientists prefer that file format, and that's what the data lakehouse will give them. And then even though storage is cheap, you only have one copy of the data, so you can save a bit of money that way. Now, everything has trade-offs, and to open a can of worms is, if I skip the relational database, these are the things that I have to think about that are the trade-offs. One is speed. The queries will always be faster against a relational storage in there, especially if they have technology like massive parallel processing And the data lake doesn't have things like clustered comps or indexes or statistics or caching or query plans, materialized views, or they have some of it, but it's just not nearly as advanced as what you see in a relational database. So you have to think of that. Now, you could run queries against Delta Lake and they take 5 seconds, and that could be fine. But if you needed to get it into a second or milliseconds in there, then maybe that particular piece of data should be copied. It's not an all or nothing. We don't have to say everything in a data lake has to go into a relational data warehouse in there, but just a subset of the data that you need to get around some of these problems in there. Things like role of security I talked about don't exist in a Delta Lake. You could have trouble with concurrency. If 1,000 of people are trying to access the same file, that could not work well within a Delta Lake, but work fine in a relational data warehouse in there. There are features that don't find in a Delta Lake, like referential integrity, and so that's a big concern. Then maybe a relational data warehouse would be the way to go for that piece of data in there. It's a big one too. Is if you're using Databricks and you're going against the data lakehouse, you'll have to use Spark SQL on there, and that may not be a problem unless I go to a customer and they say, look, we have 100 people who have been using T-SQL, and now they have to learn something different. Even though it's not that much different, it's something to consider, that all the training that has to go into play. And then there's the product has to support the Delta Lake, and then people could be just used to that relational database in there, whether you have to force metadata layer on that. So it's a lot easier to find data because you have the metadata on top of the data. In a Delta Lake, the metadata could be embedded within the file itself. It could be separate in a file. It could not even exist. So it could be challenging for people to find data in a Delta Lake. And therefore, sometimes it may be worthwhile to do the extra work to put it into a relational data warehouse. Now, a lot of these concerns have gone away with products like Synapse and Power BI. For example, I can import the data from a Delta Lake into Power BI, and which behind the scenes is a tabular model. It puts it in memory, and query response time are milliseconds, so you can run dashboards against it. Power BI also has role of security, so you can say I don't have to worry about that problem anymore. Synapse and now with Fabric in there can have first of all, a tremendous cost saving because you only pay as you go, and then they could have features on there such as the ability to create views on top of a file sitting in the Delta Lake on there, and that view has metadata on top of it, and anybody else then can call that view to query that data. So I can use Power BI or Tableau and call that view, and then add additional functionality to that view using T-SQL. So I can get around having to use Spark SQL by creating a view. And so the end user will think that the data is actually sitting in a relational data warehouse in there, because that's where views usually come from. But no, actually, it could be going against a file on that. So it takes away that problem of not being able to use T-SQL now. And this is Microsoft Fabric that was announced yesterday. It's a lakehouse. In Synapse, you have a serverless pool that goes against files, and then you have a dedicated pool that is goes against relational storage. So that gets back to the first modern data warehouse. And within Fabric, they have gotten rid of the relational storage in a dedicated pool. Everything is inside of a Delta Lake. Now there's a Lakehouse, and you have that to be used in a lot of cases. If you like Spark and you want to have access to notebooks to use it, you can create a Lakehouse. And there's also the option to create a warehouse, except that warehouse is stored in Delta format on there. And there are intricacies of the difference between the two, but if you are someone who wants to stay in the T-SQL world, you can create a Lakehouse. If you're more of a Spark person, if you're in T-SQL world, you'll create a warehouse. If you're a Spark person, you create the Lakehouse in there. Both of them can use T-SQL. The difference is with something in the Lakehouse, you do updates with Spark, and with the warehouse, you do updates with T-SQL on that. But behind the scenes, everything is in Delta format in there. So that's where we've gone. Microsoft has gone to the true data lakehouse in there. There's just different interfaces that you can use on top of that data, but everything is in a Delta Lake. So there is only one copy of the data. And because Delta Lake's open source, you can use it outside of Microsoft Fabric. So if I want to use Databricks against that data, it can go and do it on that, or any other product. All right, so just drop in comments as if you need be on there. And now we will jump into the data mesh. Everything I've talked about is centralizing the data. Now, the big change with mesh is it's decentralized. And this is the confusing part, because not everything in data mesh is decentralized in there. But as I'll talk about, the main functionality you get in a data mesh is a decentralized approach for the infrastructure and for the organizational people involved in that. So we'll jump more into that. All got a couple questions. What would be an approach for data governance in Fabric? Is it integration with Purview or something else? So Fabric is in public preview, and it does not yet have integration with Purview, but that's coming, and that will be there before GAs. So like it is integrated with Synapse, it'll be in Fabric. And so that'll be your data catalog. That'll be a way to see what other people have already ingested, which becomes especially important with Fabric because it's available to any Power BI user. If some admin in your company turns it on, everybody can start using it. And so they will want to use Purview to make sure they're not reinventing the wheel. So you will see Purview integration in that hopefully soon. And then what would be the recommended master data management tool for Fabric? So Synapse, or I should say Microsoft, does not have an MDM tool. And that's where we recommend third parties in there. Ones like Informatica or Prophecy, they have those MDM tools. And Prophecy has integrated very nicely within Synapse, and then they're going to integrate with Fabric. So within your pipelines you're creating within Fabric, you can pull in Prophecy MDM task within that. So you can do that now in Azure Data Factory, and within Fabric they have pipelines and I won't get into it, but they have data flows in there, and those will eventually have Prophecy and probably other third parties integration in that. So thanks for those questions. Okay, so looking at and feel free to just keep dropping your questions in there and I'll check it. So when we get into the data mesh world, it's important to understand this is a concept. There's nothing to do with technology, and it's a huge organizational and culture shift. So it's think of it as and this is where it gets into the problems. It sounds great in theory, but if the technology is not there, it could be very difficult to implement a data mesh on that. But the ideas are great, and even if you don't implement a data mesh, learning about a data mesh can help you in whatever path you go down, whatever architecture. These principles could apply really to anything, any architecture that you build. And this took me a long time to come down to get these 4 principles and simplify them. The first is domain ownership. The idea is the people closest to the data should maintain ownership. So if I, for example, have a company and we have manufacturing, sales, and supplier groups, now they're copying the data into IT and centralizing it, and then IT owns the data now. And we're getting away from that, and we're saying no, the domains keep ownership of the data, and they know it best, so they should maintain the ownership. They should also, getting the principle 2 is treat data as a product, meaning the domains, instead of copying their operational data to IT, they will keep it and create the analytical data themselves. They will create domain teams. They will fire up their own infrastructure. They will have some contract to follow that every domain needs to follow to make their data available outside of their domain to other domains or to consumers through maybe API calls that can call not only the data but the metadata to find out what the domain has. So you're putting that responsibility of creating that analytical data with the domain. Now, this is where that domain could decide to use a modern data warehouse or a data fabric. And so this is where these architectures are not all are competing, but rather they work together. So each domain ideally can do whatever they want architecture-wise, and this is the big change. This is where the domains now have to have their own domain teams and infrastructure. So the benefit of that is now you can scale. The more domains you have, the more people you have to scale, because each domain is going to hire their own team. Each domain is going to have their own infrastructure. So more domains, more infrastructure. So this is the way the two big things are, that organizational and infrastructure scaling. So IT doesn't become a bottleneck for not only people, but the technology could not handle all the data. And so this is a big part of a data mesh, is treating data as a product. Now, each domain, if they're going to go and build their own solution, can we shortcut the process for them? This is where 3 and 4 come into play. The idea is, can a central team create some infrastructure automation where ideally you click a button, it asks you a few questions, what's your domain name? And it builds out the infrastructure, the storage, the compute, the ETL, the security. So each domain is not having to go and do it on their own. That's infrastructure as a platform. And then 4, federated computational governance, the idea is a central team, or could be a collection of people from domains, are going to come up with a playbook for global rules. And this is going to make sure each domain then follows some standardized approach, because you don't want each domain deciding to use different security or even different data quality of how they're going to clean the data or modeling the data, or these are the regulations that should follow. So that playbook is created and given to each of those domains for them to follow. Now, maybe there are some rules that can be implemented globally by a central team, but in most cases, that's why it's federated. The local teams are going to implement those rules. And so you want to ideally have 3 and 4 done before you start with number 2, because you give them those shortcut tools in there. And that's data mesh. It's those 4 principles. There's nothing about technology in here. And this is where it gets confusing, because it's, well, some customers say they built a data mesh, but then when you dig into it, they may not be following these principles. Maybe they're following 3 or 2 of these principles. Can we even call it a data mesh? Sometimes customers are doing 2 principles, but only maybe halfway. Well, I don't care. You want to call it data mesh? That's fine, but it may not actually be data mesh. It may be more like a data lakehouse with 50 workspaces that are each domains in there. So this is where we get a lot of the confusion of everybody calling everything a data mesh when it may not really be a data mesh. And so the use case for data mesh is solves that ownership problem. It generally solves quality problems, because instead of IT cleaning the data, who may not know the data very well, you have the people own the data, so the data quality should be improved. And then the other 2 I mentioned is the organizational and technical scaling are greatly enhanced with data mesh. And the big challenge with data mesh is creating data domains. I said manufacturing HR, but the reality is it's going to be very complex, and customers can spend months deciding how are we going to break out the domains. Like examples here, you can be marketing, customer service, and order management. Within each of those, they have data products. They could have 1 to dozens of data products in there. And how do we break this out? Usually by business capability, and that can involve a lot of reorganization of teams. And that's where a lot of culture change comes in. This is where there's a lot of pushback from customers, because they just can't get that type of change going in their company. And you may have a logical architecture then that looks something like this. You have these domains, manufacturing, sales, supplier, and those are source aligned domains. And Jamek, who came up with the data mesh, also defined other kind of domains, two other ones. One is a consumer aligned, because the source may be easy for people within the source to understand the terminology and the way its data is laid out, but it may be too difficult for consumers. So you might want to copy that data into a consumer aligned domain that is a lot easier for consumers or other domains to make sense of that. Also aggregate domains, because there's going to be a lot of times when you're going to need to combine data from multiple domains. What happens if I have 100 domains and I need to take data from 30 of them? The performance is going to be terrible for whatever type of query I try to pull that data, because each of those domains could have their own data lake house on there. And so the idea is you create an aggregate domain that will help the performance on there. Now, this is where I have a little bit of problem with the data mesh, because the whole idea is be decentralized. If you're aggregating the data, you're putting it in a central location, which kind of goes against the idea of a data mesh. And then who owns that data and who takes care of it? And this is where trade-offs were made for performance reasons that confuse people. And then there's a lot of concerns with data mesh. In my book, I have like 50 of them, and I'm not trying to say you shouldn't do a data mesh or bash it. Just think of these concerns, just like any of the architectures. And if you go through them all and you go like, hey, no problem, then build the data mesh. Or maybe there's some other problem and you find ways around it. But a lot of times with customers, the data mesh is going to be not ideal for them because of the concerns I listed here. And just to point out a couple, it's huge investment in organizational change, and people hate change. So that's really hard to get buy-in from every group on that. The performance can be a problem, like I mentioned in there. And there's a lot of data duplication, because you'll have domains copying data to other domains in there. And then that could be a problem of consistency and whatnot. So just think through these things, read about them, and then see if that's going to be blockers to building a data mesh, or if it's something you can get by with. Zamek herself has in here when you should think about adopting a data mesh, you should score higher or medium on all these categories in here. And this is where I find 99% of companies don't score medium or higher on all these. Now, maybe they will in the future, and they can make changes now to do that. But a lot of customers look at this and go, look, we're not domain oriented. We're not tech at core. We're not early adapters in there. So a data mesh becomes something that, yeah, we don't want to go down that route. However, as I mentioned before, learn about data mesh and maybe take some of those principles, especially domain ownership, and say, well, let's build domain ownership, but within a modern data warehouse or a data fabric or a data lakehouse. And then lastly, just a couple of slides, data mesh from Azure. There's not a lot to talk about because the technology is not part of data mesh. Now, obviously you need technology to build it, but mostly it's about those concepts and organizational change. Now, there are tools like Cloud Scale Analytics that Microsoft has, and now Microsoft Fabric, that could be used for that third principle to help you shortcut the building process on that. And I'll have more about that in future blogs and presentations on there. But those are pieces of technology that maybe can give you 25%, maybe 50% of what each domain would need in order to get started. And you would come out with something like this, which again will be updated with Fabric. But if you're looking at the Synapse world in there, you may have a management landing zone that oversees all these data landing zones. Each of those data landing zones are for each particular domain to have their own environment on there. And this is where you get different mesh types, because I don't think you'll see anybody ever build mesh type 3, which is each domain can do whatever they want technology wise. What I'm seeing mostly with customers is mesh type 1, where they limit the technology they can use. And within the data lake, instead of having each customer having their own data lake house, or each domain, they have one data lake house, and they just divide it up in folders, and each domain has their own folder that only they can access. So it's a logical data lake, which is really pertinent with data fabric and what they call one lake. And it's a way you can create shortcuts to other data lakes in there, But even with that, if those other data lakes are across the country, across the world, it could cause performance problems. So I could have one physically located storage with those folders in there, so I get the performance I need. And so I think the data mesh future is going to be a mixture. If customers, those few that do go down the data mesh, they're going to have a centralized approach, especially as they migrate, and they'll start popping up other data meshes, domains for the data mesh in there. Maybe it's a new domain, maybe they pop out a few, and then over time they pop out more. But all it takes is one domain to say, look, I'm not going to give you I'm not going to do it what you said. I'm not going to build it. I can barely keep things going. If you want my operational data for analytics, take it. Well, you're going to have a centralized solution for that. And so that's where I think it'll be combination. And so when we look at all these architectures, I think of the modern data warehouse. Now I would only recommend a small amount of data. And if you have anything more complicated, especially streaming, you want to go into data fabric. But now the data lakehouse, I start telling customers, do it until you can't, especially with fabric. If you find as you go along without using relational storage, if you have a problem with that particular set of data, then maybe you copy that to a relational data warehouse, or maybe now you'll copy it to a Power BI model in there, but getting away from having relational storage. And then a data mesh is just for very large domain-oriented companies that are already having major pain points with scaling and have a very long timeline. That may be best for the data mesh. Bottom line, take bits and pieces of each of these and customize it to your particular use case. And that's why there's no set playbook for everybody to use. It's all going to be a combination of understanding the data that you want to ingest now and in the future, and building the appropriate architecture that can last you a long time. I'll make this deck available. There are some of my favorite resources on here. My upcoming book is going to go in much more detail about this. The first 2 chapters are out. So if you have an O'Reilly subscription, you can access them. If you don't, just email me. There's my email. Send it to me. I'll give you the first 2 chapters in there. If you have any follow-up questions, just let me know, and I'm happy to answer that. So that's it. I know I only have like a minute, but if there's any other questions, just pop them in there.
Yes. Thank you, James. Perfect timing. We have just one question from our audience. What is the best practice to share data sets between different domains in the data mesh? And maybe it's, yes, we understand fully that data mesh, it's architectural approach. It's not about technology. But in this case, as I know Oleg, maybe his question addressed to Azure, because, for example, in Snowflake or Google BigQuery, we have really approached to share these data products with another domains, and maybe you can share with us some best practices, what we can do in Azure.
Yeah, and so if I have a domain and they have data sets in there, and now if other domains want to use that data set, well, I can do the old school way of just copy that data over, and then they can ingest it. Or I can use a product like Metaverse data sharing, so you can track where the copies are in there. Or I can even do Immerse sharing in there. So maybe I don't want to copy the data, but give them pointers to the data. And that's more going to be popular with Microsoft Fabric on that. Of course, the trade-offs then are performance on there. And this is where, bottom line is, sometimes you may need to copy all the data into one aggregate domain to get the performance you need, or copy it all into like Power BI on that, and create a data set there and then share it that way. So this is where there's so many combinations that I have to sit down with customers and whiteboard it out, their particular use case, what their skill sets are, and then come up with what's going to work best for their particular set of data, size, speed, and type.
Okay, great, I see. But maybe general idea is behind separation between compute storage and compute and storage, yes? And maybe if possible somehow on Azure to share just data without allocating compute resources, and with this, they don't copying everything, just sharing data in this case.
Yeah, and that's a big change in the last few years, the separation between compute and storage on that. So you have that Delta Lake, I have all the data in there, and then whatever compute I want to bring up, if it understands Delta Lake, which is really much everything now, it can go and use that data. So however it wants to copy it or share it, it has the ability. And that's one thing that separates out Microsoft Fabric and maybe some of our competitors is everything's stored in Delta Lake, open sourced. It's not proprietary technology. So you can go and build all this stuff in Fabric and land it into a Delta Lake, and then you can do stuff outside of it with any other product you want. You're not forced to use Fabric and its compute on there. And so that's the big thing, and which I'm really glad Microsoft took that approach, is standardizing on open source Delta Lake. So you're not locked in.
Okay. And I want to summarize this comment from Olha Nazarenko, that it was the really great overview. And thank you, James, for your session. And for everyone, I want to announce a short pause for 3 minutes, and we will meet in 17:35. Okay. See you soon. Thank you again, James.
Okay, hello everyone, and right now I'm ready to introduce our panel discussion on the subject of the future of data engineering and big data. And right now I will be adding our moderator, Rodion Myronov, who is also our director of big data and analytics at SoftServe. And I'm just will probably pass the word to you. I'll just add all the rest of the panelists. I can see Joe Reis is here. Here we have Thiago, and I can see that Emilie is also there, but I'm guessing she might be reconnecting. So oh, she is there. So good to see you all here. So I'm passing the floor to you. So I'm sure you're going to have an amazing and joyful time. See you soon.
Thank you. Thank you so much, Victoria. Nice to see you, my colleagues and co-panelists here today. And nice to virtually see, imaginary see all the attendants of the Big Data Fest conference. Let's start with a short round of introductions of people who are currently in this panel, and then we'll jump to our topic. I will kick it off. My name is Rodion Myronov, as Victoria mentioned. I'm basically a data guy with 20-something years of experience doing all kind of data projects, starting with FoxPro 2.6 for DOS, which was amazing, by the way, and all the way through relational databases and Hadoops and clouds and Hadoop in the clouds and so on. Oh, wow. Another participant, Joe. I will be asking you to introduce that one as well. So for the last several years, I have an honor to lead Big Data and Analytics Center of Excellence here in SoftServe, and today I will be moderating our discussion. And back to you guys. Joe, can you please start?
This is the anticipation of who's next. Yeah, hi, I'm Joe Reis, recovering data scientist, co-author of this book. Happy to be here.
Great, thank you. And your co-panelist today? I mean, the one that tried to join.
Yeah, this one here. This is my golden doodle, Lana. So she accompanies me everywhere I go. So she'll probably have smarter things to say than we do. So
great.
Anyway, good to see you.
Okay, great. Good to see you too. Emilie, can you be the next?
Sure. So my name is Emilie. I am part of the national board for the Center for AI Pioneers in Denmark. On top, I am a director of data and for a Norwegian company called the Mistone Expert. I've been working with data for the past 12 years. And it started with very normal enterprise data and went over to being online big data. And now I've gotten sort of all around in both working with machine learning, AI, data science, data engineering. So that's my background.
Great. Thank you. Nice to meet you. And Thiago?
Amazing. Yes. Hey, everyone. I'm Thiago. Yeah, working with a lot of things related to data for several years. Usually the least intelligent person in the rooms that I am, and that's how I like to live my life on. And looking forward to learn, share, and understand how things are going.
Just for the record, Thiago, nobody ever believes people who tell that about themselves, about being the least intelligent person in the room.
I'm actually dumber. We can turn this into a contest. Yeah. So
let's make this a competition, Joe. I can guarantee.
We can see who can say the dumbest thing possible. That'd be great. So, it's gonna be a great panel.
Okay. Yep. Great. Okay, guys. So let me start our discussion with a bit of provocative topic and still important one. Let's put it this way. 20 years ago, if you would say big data, nobody would understand what you're talking about. 10 years ago, or almost nobody, okay, 10 years ago, if you would say big data, everyone would know exactly what you're talking about, and it would be Hadoop and its zoo of services. Nowadays, when we say big data, I'm not quite sure all the people or the community in general is on the same page about what is big data, what the term even mean. And yet here we are on the event called Big Data Fest. So may I ask you to start with your definition or your thoughts around the term big data now in 2023, if it's relevant, and what does it actually mean nowadays?
I think that Joe and I are on the same page here, so go on, Joe.
I think it's a good name for conferences. I'm even when big data was a term that was in vogue at the height of its popularity, I wondered what it meant. There's obviously the classical definition of the 3 V's of big data. So velocity, volume, veracity. But at the same time, I didn't. Back then, I think people took the volume as the V that they were most concerned with, and so it was always this contest to see who could have the biggest size of data. But back then, it was in retrospect, it was laughably low amounts anyway, because it was like gigs or terabytes of data. In which case, it's like you can fit all that in your phone right now. That's not that interesting. So I tend to think of big data as more of a sort of a complexity question. If you're gonna dive into it, like what's a complexity of maybe a distributed system that's handling this data. But even then, I think that's becoming a bit kind of old hat at this point. Jordan Tigani from MotherDuck had a really good article that said big data is dead. I do agree with a lot of his sentiments on that and his thesis. He was one of the people I think responsible for creating the infrastructure for big data at Google, for example. So I think he knows of which he speaks. But yeah, so I don't know. I mean, it's relevant, I suppose, but it's a very antiquated term at this point. So I just think of data as data. I always have, though. Curious what other people think, though.
Yeah.
Yeah, I
Welcome
think
back,
I
Emilie.
think that I'm on the same place. Oh yeah, welcome, Emily. I think that I'm on the same place here. That even when it started, when I used Hadoop for the first time, and the big table paper came, and like all of it, well, what was big for Yahoo, what was big for Google is very different than what is big for engineers starting to work or a startup and working on the edge or loading things into memory. So to me, it's always a relativistic kind of question. I am 172, and I live in the Netherlands. I'm quite a small person in Brazil and like really small in the Netherlands, and that's relative. And I think that data is on the same perspective, depending on the use case, depending on the storage, depending on the thing. It adds a lot of complexity into the things that you were dealing, and then you have to utilize different methodologies and things on it. So, yeah, I don't think that the term has a unique definition. It's quite relative.
Okay. Thank you. Emilie, I'm not sure if you were able to catch the beginning of this discussion. We are talking about whether the term big data is relevant nowadays and what it actually means nowadays. And it seems like the video is frozen. So let's move on for now. Guys, I'm with you on the term of complexity. And when I try to think about it, and actually for me it's a practical question because my center of excellence is SoftServe in called big data and analytics, and from time to time I wonder, should we call ourselves just data and analytics? Well, we actually are doing projects that are not huge in terms of data, but huge in terms of complexity. And well, if we check the historical perspective, we didn't really have people who were data engineers, or at least the name for that, 20-something years ago. We had database engineers, like people who do their Oracle DB2 or whatever. We had DBAs, people who are deeper specialists in the infrastructure for that. And that's about it, right? There were no notion of person who does everything with data. Then it was all things Hadoop. And right now, the complexity of the landscape is really huge in terms of the services we use for all things data. Like literally for every task, we have at least 3 leading cloud providers with their own solutions, plus at least 3 other cross-cloud solutions, plus open source. That's a lot. And if anything, if I would be coining the term for alternative term for big data right now, and I would be obliged to use something but just data, I would probably call it wide data because of the wideness of the stack, and maybe complex data. But I'm also agree with you, John, that the term is good, the term is well known, and we are following it simply because it's a tradition. And what we mean when we say big data is data-centric projects, data-centric people.
Well, and to add something to this too, I remember talking with Jordan Tigani about this, again, the person I referenced earlier who said that big data is dead. And he was the first engineer on BigQuery, Google Cloud's analytical database. And I think the way he described it really well, where BigQuery can definitely handle huge amounts of data, right? As much as you can throw at it. But it can also handle like kilobytes of data if you want it. So I thought he had a really good point where he called it easy data, or he called it easy query is what he called the BigQuery actually, because it was just super easy to use. And I think that's more of the trend where everything is going. There's this high level of abstraction and simple to use interfaces, hiding a lot of behind the scenes complexity, but the user doesn't need to care. And I think that's kind of where we are in today's age.
Yeah, easy data is a cool brand. Should probably be registered by someone. All right. So talking about that historical perspective and how the landscape changes over time, do you think, guys, you can mention a couple of trends you currently see in terms of where the market is going, in terms of what customers are trying to implement in their big data and analytics space?
You want to go first, Thiago? I spoke last.
Yeah. I think it's really, really easy for me now to predict because nobody's gonna 5 years from now check Thiago said that and it was right or it was wrong. So it's
That's the
quite
right expert
straightforward.
approach. Yeah.
Because in tech, it's hard to predict what's going to happen in 1 year from now. 5 years, oof. But I do think we are starting to see enterprises and other places that were not data centric moving towards the concept of streaming APIs, and I think that is going to become more and more relevant in the upcoming years. That teams are stopped to just produce something and dump into a data store, but actually produce an API that can be consumed, utilizing that as data products. It sounds quite 5 years ago for us living in the O'Reilly bubbles and like going into this conference and like all of it, but you'll be surprised the amount of enterprises that haven't reached that maturity stage yet. And the other point that I find it's quite relevant now is where data warehousing is going. If data warehousing is going to exist a little bit as we know, even with the concept of the snowflakes and the cloud data warehousing systems that we see now as the last big thing in the last 3 years, where is that going? And also, as something that I see is the integration with the large language models and the machine learning part, because so far we've treated data pipelines quite separate from the AI/ML part. And I think that is going to become much more ubiquitous, just one pipeline to train, retrain, enhance, and like all of it. And I see companies that are now building their data pipelines in the cloud native fashion, and they have their AI/ML in a cloud native fashion, but they're still split. And I think that is going to become one thing. And I'm quite curious to see how that is going to pay out.
Yeah, I agree. It's kind of weird. I think you could just like interchange Thiago and me and probably have the same answers. Yeah, I largely agree with what he said. I think the sort of, when the modern data set came on the scene back in, I pinpointed at 2012 when Redshift became available. I think that was the first time you had if you're going to define the modern data stack as, composable systems that you can buy with a credit card really cheaply and modularly, then I would pinpoint a Redshift as being exactly that. But fast forward to today, the modern data stack is still being rolled out, and I lump that in with just commoditized data warehousing, democratized data warehousing, and various components in that ecosystem. But as Thiago points out, and I definitely agree, the streaming is undergoing a very similar transition at this point, where a lot of the complex tools, typical streaming services, Kafka and Pulsar and so forth, transformations like Flink. I mean, all these are being, simplified and abstracted either behind companies or the products just continue to evolve. And I think that's going to be another secular trend that continues. Large language models are, I've been thinking about how that impacts, everything. My friend Ryan Dolly and I have been talking about this, where I think it for analysts, it presents a new interface, and maybe it changes the work of what analysts do. And so that's how that impacts the rest of the data stack. I'm TBD. I'm trying to noodle on how large language models might impact data modeling, for example. But I mean, I guess I just need to sit down and figure it out. But yeah, there's a lot of trends. But at the same time, it's an interesting one, because if you zoom out, it's still the fact that most companies are barely doing BI, let alone AI. And so I think it depends on where, Geoffrey Moore and his book Crossing the Chasm describes, the early adopters, sort of mid-tier, and the laggards, and late adopters and so forth. So I think it really depends where on that curve a lot of companies are. And at least from where I sit, a lot of companies are still stuck, trying to do things like move to the cloud, for example, right? And so I think it depends on the stage of company that you're also, putting in this context. I mean, there's always, as Thiago pointed out, there's the O'Reilly bubble that we might be in. But I think that tends to be about 5, 10 or more years ahead of where just the world happens to be. I still get calls all the time from people saying, yeah, we're thinking about data warehousing. I'm like, that's been around since like Bill Inman, published the term in 1989, right? Like that's old enough to have kids at this point and almost grandkids. So like,
yeah. So actually, a good point on us being in our technological bubble and describing, perceiving the industry as moving forward, coining new terms, developing new technologies, and business, our customers, people who we work for, being, well, I wouldn't say stuck, but maybe I should, being stuck on quite a basic tasks day by day, year by year, decade by decade. You mentioned Bill Inman, for example, and Thiago, you were talking about data warehouses as and their commoditization as a trend. And if we had Bill Inman here in this discussion, Bill, I follow LinkedIn, so I think I know the point of view. Bill would like to mention that vendors developing new technologies and new marketing terms are undermining the value of industry, the value of data progress, because they are not paying attention to something fundamental, like, for example, data modeling. And Bill would be very loud and clear about lake houses or simply new products not replacing, not being able to replace the discipline and science of data modeling. Would you agree with that term? Do you think data modeling is a thing right now and is an important thing?
So I do think that data modeling is important, but I do think that there is a lot of precious caretaking of what people mean by data modeling, because modeling the data at the application level is also data modeling. But it's just that sometimes you want to keep that on the infrastructure side or on the closer to the storage side, like all of it. But that's the same discussion that we can have about imperative coding or executive coding, or about type safe or non-type safe. Like, it has its pros and it has its cons where you put the data modeling there. I come from the world of startups. Like, even before joining AWS and like when I was over there, I mainly working with startups. We cannot discuss with someone that wants to innovate. Let's spend 1 or 2 weeks working on your data model so heavily and like normalize and like do this because we need to get that right. That's a bank problem because they cannot make that mistake. So I think that it's the old, it depends. I see there is a lot of value. I see a lot of people just push forward data modeling because it's hard. But I also do see a lot of precious caretaking of, we should do like we did in the 90s when we had a database administrator taking care of the visual perspective on how we did data modeling with the UML before we push into the Oracle 5 or something like this. I think that there is a middle ground there.
Yeah, I mean, so I guess I'm fortunate enough to call Bill Inman a really good friend of mine, and I talk to him almost every day. So,
wow.
So I think I can kind of predict what he would say.
You can provide a better perspective than me.
Well, I mean, he and I do agree with him a lot. I mean, I'm somewhat of a protege of his, but I would say, like, you got to get back to basics, right? There's a all too often, IT and the business, as he calls it, there's a large decoupling. He might dare call it a divorce. Data modeling, I would say, is there's the physical data model that we all talk about, like relational modeling, dimensional modeling, data vault, and so forth. I'm currently working on a book on data modeling, actually, and the perspective I'm taking is it's we're, as an industry, we're missing the entire picture here. We're missing the bigger picture of what a data model is. When you take a step back and understand what should a data model be, it's about expressing business concepts, business rules, business processes, and data workflows at a high level, and then translating that down to the implementation level, regardless of whether you're using a relational database, a NoSQL database, a data warehouse, machine learning models, or whatever. Like, how does data flow through its data lifecycle And how does it morph along the way? Or because data does, right? It's created and something happens to it and something else happens to it and so forth. Every time something happens, that is a model, whether you call it a model or not. You're trying to represent the reality of your business, you know, and all the subsequent rules and processes in it. And so I you know, what I'm advocating for is taking a step back. And as Thiago points out, I think there's a lot of friction right now with data modeling because I think people take the physical first approach, like, well, we got to spend a lot of time, you know, rigorously modeling this in ERD. And I'm like, I think that's actually completely backwards. You know, take the time, and you know, if you're building a house, for example, you want to understand, like, what's the point of it? What's it gonna do? What do I want? And so forth. You know, that's a lot like modeling. It can be done in a very agile fashion. You know, even at a conceptual or logical level. And that's what I'm advocating for. And then the most important place to get the model right is upstream when data is created. If you can't get it right there, then everybody else downhill gets to deal with the consequence of that. That's why you hear the old trope that data scientists spend 80%, 90% of their time getting data, cleaning data, figuring out data. It's because the data upstream they're dealing with is, you know, it's as much a victim as anything else. Nobody put a lot of thought into it. And so I think it's the incentives that also go into this, as Thiago was quickly pointed out, where if you're in an environment where you don't have a lot of time to think through and be intentional about the data that you're using, you're going to get what you put into it. It's just like everything else in life. You know, I mean, we can always talk about living a good life and having a good diet and exercising and all that stuff. You know, if you're not going to put the time into it, then I suppose you're going to get what you put into it. And then data modeling is very much like that. But what I see as one of the root causes of why we have issues with data and why we have things like, I don't know, contracts, you know, all these other things, which I think are great, but they also address the symptoms, not the cause. I think we got to get back to basics. And I think really come to an understanding of not just the physical implementations of data models along the way, but the higher level meanings. And that gives us a chance to work with the business rather than like trying to interpret what the business wants, which I think right now the role of the data team is very much being a mind reader. So hope we can get out of that.
And that's where I see a lot of the going back and circling back to domain-driven design in a sense of
Bingo.
not to go and to talk about you should do other things and talk about the ubiquitous language and like all of that. But I think we should have a common understanding and a knowledge about the business and to understand when this data enter my system, I'm gonna in the end serve this actor or this user or this. How am I gonna do that? Okay, how do I do the data lineage there? Or is it important? How does it matter? How am I going to do that? So understanding the domain and the business that you are and how it affects every step of it, that's what every developer, data science, everyone working with that data should be aware. If they map that in a physical place, in a logical place, whatever, use the tool that you think is best for you. But if you document that, then you have gold on your hands.
Yeah, and it takes us back, Thiago, to one of the concepts you've mentioned before, data products implemented better than just dumping data somewhere and calling it data lake. And obviously to the whole concept of data mesh, which is, I believe, a topic of a separate discussion in this very conference. So we will not be diving too much there, but it's fair to say that right now a lot of customers are thinking about decentralizing their data initiatives, transferring ownership, transferring responsibility, transferring ability to build data products somewhere from central IT/analytics/whatever team to maybe business users, maybe somebody they call resident developers or resident data scientists within lines of business. Do you have this trend? And maybe you if you see this trend, maybe you can also highlight some difficulties companies are facing on this road.
Please go on, Joe.
Sorry, I got distracted by that. What was the core of your question again?
The core of the question was all about difficulties companies are facing when they try to move towards decentralization data products and data meshy architectures.
Well, I'm trusting people have heard of Conway's law before. If they haven't, I'll briefly describe it. Conway Sawyer describes this phenomenon you'll see in every business where you'll design systems design your systems according to the way that you communicate in a nutshell, right? So if you happen to be very siloed, your systems of communication will be very siloed. And the systems you build and the architectures will represent that siloed reality that you have. So decentralization, I would say, it requires situational awareness of the type of company that you're in. If you're in a very command and control, top-down, siloed company, then decentralization probably won't work. It's no different than an organ transplant getting rejected by the host. It's like, ain't gonna work. Don't like this. So, and I've seen this before, right? I've seen this many times actually, where some new exec comes in, says, "Oh, we're gonna shake things up," and lo and behold, a few months later, that person is very frustrated, and I get to play the role of therapist, and there's that. But I think it can work, depending if there's a willingness, even in an old school organization, to make a change and decentralize. This is obviously a very this is the hardest part. Implementing decentralized technologies after that is, like, I would say, a bit easier, but like just getting there is going to be your hardest part. So but it isn't a technical implementation. It's very much an organizational change, and this is infinitely harder than implementing a data mesh or a fabric or whatever. I don't know. What do you think, Thiago?
Yeah, and I think it's quite unique that you mentioned that, because for the last 6 months I've been noticing with my customers and people that I work, like, a contrary tendency to centralize back, because maybe I've been working in companies and startups that were quite decentralized, and they grew up to some point that they need to standardize a little bit more, and then they start to centralize things a little bit more. And I always see this pendulum in IT. We go from here to there, from here to there, from here to there, and it goes in the same way that Joe said. Like, it's been decentralizing for 5 years. Now you start to see much more the cons of decentralization, and a new person joins us and convinces everyone that there are so much pros if you centralize, and then we start centralizing it back, and maybe 5 years from now we're going to decentralize, and a different concept is going to come in. What I find interesting of it, especially on data science and companies that haven't spent too much time structuring their data science teams, is lots of them are centralizing, or they are centralizing them in business units, because they let their data science run loose for a long time, and they consider their products to be over when they had an accuracy on their Jupyter notebook and made a PPT presentation about it. And that didn't add any value to the business. And now they are being asked to be part of a product team that actually delivers something. And then they start like, what? Do I need to be on calls now? Do I have to build an API? That's not what data science does. And we start to see that trend back on it. But again, I think it varies a lot from company to company, place to place. But I do see on a lot of customers nowadays a tendency to centralize.
I actually 100% or even more love the comment about opposite tendency, and the comment about us as IT and us as data world moving on something like spiral. At each and every next turn, we clearly see the difficulties of the situation we are currently in. We face the consequences of the decisions we made previously, and we tend to forget what made us to make those decisions before. So we try to fix the current situation. We end on another side of the spectrum, and we repeat it again. Like, if you recall, for example, the evolution of data processing systems, we have databases. Databases were amazing. They allowed us to build solutions quickly. SQL was great, but they became expensive and too complicated and almost a burden for developers. So we arrived to NoSQL and all kinds of Hadoop. No, we don't need SQL. We don't need complex databases. We need something simple. But guess what? People still need understandable data models, and people absolutely love their SQL as a language to consume the data. And that's how Hive and then how Spark slowly evolved towards, okay, so back to SQL. and back to more database-centric and data warehouse-like architecture, despite we call it differently. And it's pretty much the same with centralization and decentralization. People were able to see the value in bringing all the data together and deriving insights that cannot be found in individual data source. People arrived to the concept of data warehouses. It became hard to build a big data warehouse for the whole company, so people think about decentralizing. And in 5 years from now, we will be talking about how MDM, master data management, is valuable and how it helps to put together everything in data mesh architecture, and how the centralized enterprise data model is important to derive insights from disjoint data products built in the data mesh. So we will be there again, I believe.
Pendulums, right. Yeah, everything goes in pendulums.
Yeah. All right. In terms of technologies in big data, we are more like business and approach and philosophical topics. In terms of technologies, what are the big things you guys currently see on our technical horizon, technical landscape? Trends, shifts in the way people use the technology, so maybe the whole technologies people use to build data solutions.
I mean, if you're to believe a lot of the pundits out there, large language models and generative AI will just do everything for us soon, so it won't matter. But it's interesting. I think right now with the economy where it is, and at least where I am in the U.S., it's we'll see next week how the economy is actually, because we're about to default in our debt. So could be great, could be an absolute crater of a mess. But I think across the boards, companies are really evaluating the types of technologies they want to implement and deliver. Simplicity is becoming the name of the game. I think technologies and platforms that allow for easily understanding costs is something that I'm seeing a lot. Back in the day when money was a bit more available, it didn't really matter. It's like, oh, someone more computed it. It's easy. I think nowadays people are like, yeah, well, we could do that, but maybe we need to be a bit smarter about how we operate. So I think technologies that fit that profile of easy to understand, easier to implement, and help make or save money. That's where I'm seeing the push right now. So
any specific technologies that you think fit that profile? They probably will be the winners over the next 2 years or so.
I'll refrain from advocating any specific technologies in this one. I have too much attention on me, so
understandable. Okay, Thiago, anything to add?
Yeah, I think on the LLMs things and the Gen AI, and I think there is a question from someone here about it, and like if we see that it's going to democratize.
I believe some LLM models detected and predicted something that
like,
our colleague Thiago was about to say, and no. It makes me wonder if Emilie said something about LLM models as well earlier. We can check it by experimenting.
Okay, so let's avoid talking about anything regarding that.
No.
They're awesome. They're great.
We shouldn't be afraid of AI, right?
No, not at all.
Yeah,
obviously.
Okay, so, actually, back to your comment on two important things for the technologies right now, which are simplicity and ability to understand the cost. Some time ago, we were going through the list of so-called non-functional attributes for data architectures and which of them are important and which are not. And we found out that one that was not in our list before but is important right now is something we called cost predictability. With modern different billing models for different services, it's hard to compare costs directly because nobody knows workload well enough to understand how much it will cost at the end of the day. But it is at least possible to understand the model and say, okay, cost will be predictable and controlled here. it will not get out of hand with workload spiking or things like that. So yeah, a really important topic. Welcome back, Thiago. So
we thought you were killed by AI for a second. So
yeah,
actually, this
Yeah,
is it's a deep fake of him. Actually, it's not even the real one. So
yeah, I was running out of a GPU, so I had to remove myself.
all right. So you were saying that LLMs are a trend.
Oh yeah.
You see as a winning technology.
No,
Yeah.
I was talking about the fact that someone was asking about the role of the data engineer, if it's going to be democratized and how LLMs are going to play on it. And I think to me, this is just the amount of times that when you're building a data product or an AI ML that you have to spend understanding the specificities of the business and talking to people, that is not automated by any LLMs. Like I think that we are going to use LLMs and like all of those things to help us make our job easier. But the part that I add value, the big 10% that people hire me to do, that is not something that can be easily automated. So I don't have a problem with it. But there are a few things that I'm quite interested in the tech in the future. And since I'm not as big as Joe, I can share a bit. For example, Lakehouse is a technology that I've been following for the last years, and I'm quite curious to see the actual impact that it's going to have when people start to adopt a lot more. And I'm also curious about that stack above what cloud providers do. Companies like Avon and other ISVs that are building things on top of the clouds, because we see people complaining that AWS is too complex and GCP support is not that good and Azure is too entrepreneurial. But if I have something on top of it that can guarantee a few things for me, so I think there's a lot of space for ISV and for SaaS solutions to be built on it. And I think that that's a direction that I'm really, really curious to see what tech is going to be. And that's quite well related to open source. Because the same way that we had with the Hadoop part, putting those pieces together and offering an SLA and something that is reliable and scalable to people is really, really a tricky job. Running one thing in one machine in one Apache project is one thing. Running a production workload touching a lot of points, it's a completely different beast. And that's where I would place my bets on.
And what do you think should be the characteristics of open source solution on top of cloud providers to make that open source solution the next big thing in big data and analytics? Is it simplicity, maybe something else?
I would say anything you can do to get a wide community adopting it, right? I mean, you saw this with Iceberg and Snowflake recently, where Snowflake's now treating Iceberg as a first-class citizen. Like, and that's because guess what has attraction as an open source product, right? They're not doing that for every format. And so I think it's just, at the end of the day, it's like, do people like to use this thing? And if people do, then, the big platforms will come along for the ride. As the old saying goes, you fish where the fish are. So,
it goes without saying that it's not just the community, but it's like the community. But first, you need to actually solve a real pain point. And I see a lot of open source projects that are much more pet projects, and then they complain like, "Oh, this is so well documented and this, that." But it's like, yeah, it's not helping. It's not solving any specific pain point that someone would pay for it.
Mm-hmm. So, let me try to dig deeper in this. So, definitely to have a community, to make a product a successful thing for community, we also have to address some pain point of that community. We have to solve some real problem for people. Like, for example, with DBT and quite obvious but still problematic topic of orchestrating SQL-based details better than they were orchestrating before made them really successful. Do you see any other pain points right now on the market in the industry which could probably be solved? And if you have the idea for startup for that, then please do not disclose it. It's too early.
No. We can
No.
share ideas. Ideas is okay. Make them real is the problem. But I do think there is a big space yet for data governance, data quality, and like anything related to that hasn't been solved. And I'm not sure that is a technical problem, but I think that technology can be used to help on it. The solutions that we have now, even the expensive ones, as if you go into Colibra or Informatica and like all of it, they're really, really cumbersome. So
I agree.
I think there's a big space there.
It's a big space, and it's one of those spaces too where governance, I feel like that's maybe some maybe its own kind of new frontier in a way. I mean, the latest generation of engineers, if you say the word governance to people, I mean, they kind of get really cringed about that word. It's an unfortunate word, but it's the word that traditionally has been used. Governance, right? Like, who wants to deal with that? It seems lame. But to take the elements of data governance, right? I mean, there's a lot of them too. If you look at the DAMA wheel of knowledge about the data governance, it encapsulates pretty much every aspect of data. So I completely agree. There's a lot of room, and this is the missing link when it comes to data mesh too, right? Because you need the need the underlying governance layer for it to work, right? And that hasn't been solved yet, right? So we're not talking about just within companies, but the whole notion of data mesh is being able to share data across companies, and that's it's a bit of a different beast. And that but you need, if you're going to have data mesh working, which I define as a decentralized sharing of data products, then you'll need some sort of federated governance layer. That's exactly as Mac describes it too. I think that's a big frontier if anyone wants to tackle that one. So, not been done yet. Some vendors will say they have, but they haven't.
True.
Yeah, and you can go into IAMs in AWS and see how deep down the rabbit hole you can get there. And we're just talking about one case. And then you go into federating and masking and keeping the lineage. There are so many problems, and there are lots of tools that solve a specific problem if you go through a specific happy flow. But putting them all together in a easy, nice way that connects with your AD and with your Google sign-on, that handles authentication and authorization, that gives you the lineage that whenever a new team wants to consume some data and produce a new API, there are so many things that are quite cumbersome. And it becomes this cringy thing because companies decide from top to bottom to be like, we are using Colibra and this is the only way that you can do things. And everyone is building their stuff, and it becomes like security was 10 years ago. That is someone always saying no to you. You cannot move on. So maybe we need a DevSecOps Data Gov movement or something.
That's a new conference. You thought about, Thiago. Well,
yeah. All right. So basically, totally agree here. Data catalogs and data quality control systems and analysis of dependencies between data assets, cross technology and cross cloud and cross division in the company is the first class citizen problem for every big data projects right now. My criteria for the need for new products is quite simple. If I face an issue on my projects more than once or more than twice, and it is a similar issue, and I am not able to find a good product on the market, that's probably something we should work on, and the market will arrive to. And right now, one of the hottest things like that is exactly the dependency analysis, lineage, and then access management for distributed data sources. So yeah, should be a big thing right now. Maybe we should build something about it.
So I can share one fun thing just on it. I've seen a big player do a ERP system replacement worldwide, that the lineage analysis of impact worldwide, it was easily more than 50 FTEs worldwide for 9 months. Just to see what would be the impact of that ERP changes in the business.
Where was they collecting that information? Don't say Excel, please.
Sorry?
Where were they collecting the lineage information? So 50 people for 9 months, they will generate a huge amount of something. Confluence page will not do. Excel will not do. They will need another 10 people to read it for 6 months.
So this was content and diagrams and presentations and documents and like all of that to try to be better prepared for when you start pulling the plug to the new ERP system, that the things would not go down. And that is not something easy. And if you have a proper lineage thing and a proper data governance part and like all of it, that could prevent this case or help on it or speed up on it. Oof, you have a unicorn on your hands.
Yeah, I'm tempted to say that if somebody does data lineage and it is a documented diagram, something that you cannot actually query with SQL or SQL-like language, something you cannot process automatically, it's probably the data lineage done wrong. If you cannot use your data lineage system to automatically take one data asset and expand it to everything that depends on it, or everything that contributes to it, probably the data lineage strategy should be reconsidered at that point. So we are almost on time, guys. Maybe to provide some more value, we were talking a lot about value in this discussion, to the people who are attending the conference. Do you think we can each give like maybe one advice to data engineers who are listening to us on what skills to develop, what technologies to learn, where to move basically to be successful data engineers over the last 5 years and will to not be replaced by any kind of large language model anytime soon?
Thiago?
Yeah, I can go first. I can give you two things. The first one is on the things that I preach and all of it. Be kind to your coworkers, the people that work with, your customers, and everyone. That's something that it's unfathomable to think that you're not smiling, you're not having fun, and you're not making the life of people around, and people are going to enjoy having you around, and it's going to be easier to get rid of you. But that's not all, of course. I think that there is a crucial part that is, you don't write code or build pipelines or go into Colibra or build your dogs and like all of it for the sake of tech. Unless you are doing research, you don't do tech for the sake of tech. So go understand how you add value to your business. Go read Elijah's Gold Route. Go see see where your thing is going and how you add value at the end of that pipeline. Where is it used? Where is adding revenue? Where it's saving time? Like all of it, because that's the only way that you can make it better. Your job is not to build a pipeline. Your job is to make the company more profitable or more efficient, or if it is an NGO or the government, to have a better usage of the data that you have to achieve more. So focusing on the business side is quite an important thing that I think engineers overlook.
Yeah, I would say if you want to succeed as a data engineer, read Fundamentals of Data Engineering, particularly focus on the data engineering lifecycle here and the undercurrents. That's what this whole book is about. It'll give you good context in a technology agnostic way to succeed as a data engineer. And if you don't read the book, you'll utterly fail and be replaced by a large language model. So there's that.
Wonderful. Thank you, Joe. I will put a link to the book to our chat just in case people do not know where to find it. And from my side, actually, Thiago, you almost repeated what was my most valuable, from my point of view, of course, advice to data engineers. When you learn technology, it's amazing. When you can do anything with Spark and you can optimize the Spark and you can understand all the details, that's great and it makes you valuable. But what makes you indefinitely, and I would emphasize on this, I'm sorry, what makes you much more valuable data engineer is your willingness to understand a bit more about the meaning of the data you are working with and how people are going to use it, because it immediately turns the conversation from, well, tell me what to code, to, hey, I can do something for you. And that's not something large language models or any other kind of automation will achieve anytime soon. So having said that, guys, thank you very much for participating in this panel discussion with me. I hope our participants of the conference get value from it and order the book. And it will be my pleasure to talk to you again in other event. Thank you very much for contributing, and thank you for your time.
Thank you.
Thank you, everyone. I was expecting Joe to cue us with the ending song with the piano in the back, but we can wait for it.
Next time. So don't want to wake my dog. She's
Oh.
All right. All right. See you guys.
Thank you, guys.
See
Bye-bye.
everyone.
Okay, thank you everyone once again. And right now we have like 1 or 2 minutes for a really short break. And after that, we'll proceed with our next speaker, Jennifer Stirrup, and our next moderator, Vitaly Bashun.
Hey, we are SoftServe. We have offices from Guadalajara to Sofia. And we have a dog. Me. My name is Mocha. I live in HQ in Lviv. I'll tell you what SoftServe is about. We are global, and we are in love with technologies since 1993. And we have our own SoftServe University. Not every city has it. We love weird words. COE, PAX, NEXT, TSL. PAX guides our career paths. COE is our community of inventors and tech experts who foster innovation. We have OpenTech. It's our pro bono platform where we work on social projects. Open Eyes is our charity fund that helps our people and communities. We have a dedicated health and well-being program. But I'm fit enough, I think. People at SoftServe enjoy a flexible approach to work. They can work here, here, or even here. Each year, SoftServe reminds me how long I've stayed with the company. We call it anniversary and share cool gifts. But the thing I love the most is our company day. I wait for it for a whole year. And of course, we are about digital solutions. We are a hub of opportunities. Aren't happy with your current project? We have a lot of them, more than 1,000. Develop software, design new hardware, surround yourself with challenging cutting-edge technologies, or code in good old Python. What else? We are people, not machines. Mentors, not teachers. Leaders, not directors. Usually we win. Sometimes we mess up. Let's create bold things for your future. SoftServe.
All right. Hello, everyone, and welcome back to our conference, online conference after the short break. I hope you enjoyed the short video you just seen. And my name is Vitaly Bashun, and I'm going to be the moderator for the next block of speakers. And let me introduce our first speaker. Very top speaker, well known from many different conferences. She is a Amazon best-selling author, a Fortune 100 global speaker, founder and CEO at Data Relish, Jennifer Stirrup. Jennifer, I'm adding you to the stream, and welcome.
Hello there. I'm so glad to be here today, and thank you for having me along. It's been a fantastic conference so far. I've learned tons from your other speakers, so thank you for hosting this great event.
Great, great. We were happy to have you here. And you have very exciting topic today, right? And at some extent, it is still very mysterious topic, right? Metaverse, and you combine that with data and analytics, right? And you will be talking about metaverse from context, like in context of data analytics and how we can use metaverse to make decisions, to analyze data. We're excited to hear more about it. So stage
Thank
is
you.
yours, Jennifer, and have a nice presentation.
Thank you so much. I'll just start to share my screen now. So, share screen. So, hello there, and thank you so much for having me along today. It's my pleasure to be here today. So, I wanted to share with you some discussions on the metaverse and what that means for data. Now, you've heard in other sessions, for example, the last one, people talking about data engineering, and data engineering is such an important part of everything. Without proper data engineering, you won't have artificial intelligence, business intelligence, or the metaverse. It's so crucial. So I was really glad to hear that session. So I'm going to follow on from that by talking a bit about the metaverse and what that means for us as data specialists, and particularly for big data environments as well. So the metaverse is popularized in science fiction. It's now becoming closer to being a part of our daily lives through the use of social media and shopping companies, for example. So, how can businesses survive in a world where AI is becoming particularly present and the future is coming along now? So, how does the metaverse fit into the business strategy when futurist ideas are really developing at such a huge, enormous, accelerated rate? For many companies, their existing business intelligence isn't up to scratch. So, how can we move towards success with our data so we're set up for success when the metaverse arrives for us? So, that's really what I'm interested in talking and sharing information with you about today. We talk about the potential issues, complications, and benefits that these technologies could bring to us and for our organizations as well. So, who am I? I'm Jennifer Stirrup. I'm a thought leader and a data strategist. I've been in IT now for over 25 years, and I'm very glad to be here. So, please do send me a connection request on LinkedIn, follow me on Twitter, and I'll follow you back. So, how does the metaverse fit into business strategy when futurist ideas are really accelerating at such a great rate? Well, first of all, I think it's really important that we start to consider what the metaverse actually means and what it is. Now, the metaverse can mean different things to different people. It can also be called different terms as well. You may sometimes hear the metaverse described as the world's digital twin. You may hear it called the parallel digital universe. You may hear it sometimes called mirror world or the magic verse. Lots of different names, but we will stick to the metaverse for today. And the metaverse itself is really the promise of creating a 3D digital clone of the world, aligned with many real world coordinates. So the virtual world could be the next generation of the internet, and the groundwork has already been laid for this right now. So today, cloud technology is addressing processing power. We know that storage, especially for big data solutions, which we're starting to use, storage is now becoming increasingly cheap, and it's becoming more powerful to support the extended reality and more immersive interfaces. We also see that there's hyper-connected networks that are starting to leverage 5G, and those are becoming increasingly mature. Artificial intelligence itself is becoming so much more on topic. We have ChatGPT, for example, which has had another release, is becoming increasingly powerful, and it feels almost hard for people to stay up to date with it. Also, don't forget about the decentralization of finance and the economy, as it's supported by technologies such as blockchain, which is really making partly automated systems in finance possible. We also see a cultural change as well. We are now digital native consumers, and we've also had COVID, which means the consumption actually changed as more and more people moved online and customers started to demand more from virtual products. So we also have, on top of cloud, storage, people's expectations, blockchain and decentralized finance, it's also important to remember the sensors from our smartphones are constantly emitting data as well. We also have data from social media, digital devices, and we really see that the top companies are really collecting lots of data. So altogether, these things contribute to create the new cathedrals, religions, and tribal spaces for humanity ourselves. All of these things together are driving this, what we call the Fourth Industrial Revolution, also known as 4AR. And the AI-driven society 5.0 has seen more change in humanity in the past 50 years than in the past 30,000 combined. So it's a very, very interesting place to be. So what does this actually mean for our business? So let's have a look. So there's lots of hype, but is the hype actually worth anything? What does it mean? Is it worth spending your time on the metaverse? Well, the total addressable market for the metaverse could be valued between 8 trillion and 13 trillion by the year 2030, with up to 5 billion users according to City Research. Now, we see that the metaverse is probably in some sort of hype cycle at the moment. There's lots of brands just flooding into that space, investing in the technology and the data. And futurists like me come along and wonder what the virtual world is going to look like in the future. On the other hand, we do see distractors. You may have seen in the press yesterday that Meta were being criticised for burying the metaverse. And other people see the metaverse as a problem that's rather, other people can see metaverse as a solution that's looking for a problem, that it's something that nobody actually asked for. However, we know that there are millions of people who are cultivating and thriving in digital worlds, and they've been doing that for a long time. For example, the Second Life program, some of you may know that, some of you were probably very young when that was designed. But Second Life has around 600,000 monthly active users and almost 200,000 daily active users. And it's actually been going for almost 20 years. So there's a lot happening. So what's the latest news in the metaverse? So today, actually, Nanjing, the capital city of China's eastern province, actually inaugurated the China Metaverse Technology and Application Platform. And that's going to advance metaverse research and development across China. So the news about that was simply released today, and they're bringing a platform together that's going to bring together all the resources of enterprises in China, along with academic institutions as well. So they are combining research with business, and that's going to focus on metaverse and metaverse-related fields as well. So all of that is going to generate an interconnected digital realm where users can interact with one another and with computer-generated environments. So in the world at the moment, there's lots of competition to really be the hub of the metaverse development. So what does this mean for businesses? Well, what we see is that businesses can often tend to overestimate the effect of the technology in the short run and then underestimate the impact in the long run. You may have already seen this with the internet, where, if you remember the internet becoming popular, everyone said, it's going to do all sorts of amazing things. And then there was a bit of a bump, as all of these things just didn't happen immediately. So this is called the Immerse curve. We see we've got a peak of inflated expectations, which is probably where we are just now. Then people get disillusioned. And I think that's where some of the issues around Meta came around in the news this week. But then things start to level out, and we start to get a balance between risks and issues, challenges, and people starting to become more successful with it. So, So businesses are starting to work out the value that the metaverse can actually produce to their organizations. So what they're trying to do is really have a focus on exploring related technologies and exploring the impact on customers and exploring the end user impact as well. So a study by West Monroe showed that most leaders believe that there is a business value there in the metaverse, and that's for the companies as well as the industries overall. So it means that businesses are already looking at things like mixed reality, both for their employees as well as their customers and their end users. And that's starting to kick off this year. There's an increase in that. However, most executives are not really ready to start meeting and working in mixed reality environments. But all of these technologies, mixed reality, employee and customers and end users interaction, all about the data. Okay, so without the data, the metaverse is really nothing. So it's such a good place to be. So executives are the ones who will really be sponsoring metaverse initiatives in the organization. So about a fifth of executives that were interviewed by West Monroe said they were excited about the metaverse, and around half were cautiously optimistic. But even those who are not really all in still think there's some business potential. So the majority of executives overall, when you add up the figures, tend to see that the metaverse will start to bring in changes in their industry and also in their companies as well. The only thing is, it's quite difficult to be excited about the metaverse if your business is living in Excel workbooks or Power BI workbooks or Tableau, and your data is very disconnected and the data is all over the place. And unfortunately, for many businesses, that's the actual reality of where they are right now. So we'll have a little think about how businesses can start to move forward. Because the reality is that data is so important for the metaverse. What does the data actually give us? Well, the data gives us information about the interactions where the data is coming from big data sources. Okay, so we need to start to think not just about having like a single data lake to store the information, but also about how do we integrate those data sources. We also need to think about security as well. We need to think about how we can use APIs in order to give users, employees, and customers a very seamless experience when they're navigating through a metaverse digital world. For example, if you're visiting one metaverse store and then you visit another metaverse store, your experience will tell you that you expect that to be utterly seamless between going from one metaverse store to another. So that means necessarily a transfer of data. It means a transfer of data in real time in a way that is secure. So the really interesting point about the metaverse, I think, is the integration between stores. The integration that actually means that when you, as an employee or a customer, moves around the metaverse, your data has been passed off from place to place to place. That means we need to think about the APIs that are starting to hold that together to give you a very unified experience. So data is life for the universe. It's really, you could almost say that data is the lifeblood of the metaverse. The metaverse will not work without it. And what it means is that it's almost like a circulation system. The data has to move around. But as it goes round, you're going to collect more data. You're going to be able to have to think about what data you want to keep. Now, fortunately, you can start to think about applying good data principles to the metaverse now. If you don't have a good solid data foundation, then you probably won't be ready for the metaverse. So I'd suggest first things first, try and think about sorting out the data, good quality data, try to understand your data sources, and think also about things such as governance and security as well. The data needs to move around very efficiently in the process, and that's regardless of whether you are using the metaverse or not. You really need a good, solid understanding of the data. Now, I'm a consultant, I work for myself, so I see again and again companies that just don't have a grip in their data. So the first thing that you can do to get ready for the metaverse is really grab a hold of the data, understand it, be the person in the office who has a data dictionary, who understands where the fields are, who understands what the combinations of those fields mean. And don't hide that information. If you empire it, then you're actually limiting your influence in the organization. The more information and support you give to other people, the more people will see you as a thought leader and an expert in your business and your company. So this is a people skill. It sometimes feels very tempting to hide information. But if you're the master of it, then if you try and use your influence and your knowledge, then you can really build a real reputation for yourself in the company. It's a good opportunity for you in your career. So I would really recommend you get a strong grip on the data now, and that will set you up for success later in the metaverse. So that's things like data quality, data integration, APIs, make sure those are tested and working, and also engage the business as well. They will be able to tell you if they're using systems that you don't know about. I was working on a system recently, and the business users were using 4 separate systems along with a CRM solution, and the techies didn't know a thing about it. So there were 4 new APIs they had to connect to. So it's all about understanding the data better. I've put perfection here. Don't let that put you off. Also think about what good enough looks like as well. Because data will allow you to innovate. And the metaverse is all about innovation at the moment. Who's going to be there first? So how does it fit into a business strategy? Well, metaverse concepts are already relevant to the business. Customer first, customer always. The metaverse may seem a bit like a solution looking for a problem. However, at heart, every business is a data business, and every business is a tech business, okay? May not be what they're selling, but without their data and their technology, they are nothing. So for some businesses, the metaverse will be a really prominent channel in their marketing mix. And we will have to think about omni-channel strategies for working with the metaverse in terms of marketing, sales, and customer experience. Those need to be interconnected in order to really think about virtual reality. Now, in the way that we talk about cloud native and born in the cloud, companies will also have to start thinking about what it means to be metaverse native and metaverse born in the cloud, born in the metaverse, really, I would probably say. So just in the same way that we have companies that are being built without any brick or mortar presence, like mine. I have an office in London, but I don't have to use that. I can work anywhere I like. You're going to see metaverse native companies as well. So we need to think about the innovation that you can do in order to help. And the data is such a crucial part of that. Will the metaverse threaten traditional businesses? Potentially. So any new channel or economy will create competition. And getting a good grip in the data, get a good data dictionary, understand what the business interpretation of the data is, that will help you to see opportunities where you can support your company to really help them to innovate where the data is in the metaverse. Now, we see that large companies are investing in the metaverse, so they have the advantage because they can afford the risk. And there's a privilege for large companies because they can start to fail fast. But what we can see is that larger businesses maybe can't afford a larger appetite for risk. Maybe they're not nimble enough to move so fast. So we can already see that companies like Nike and Ralph Lauren are working on virtual reality branding projects that will fit into a vision for the metaverse. So the laggards, the people that are slow to catch up, they may not survive. People are already looking at this. So what are the risks? So getting a share of the market level is going to require an infrastructure investment, and for big data folks like you and I, that's going to mean storage and compute. And who's going to pay for that? So it's all about trying to get that business sponsor. We're also a bit concerned about unpredictable user engagement. So while the metaverse may support 2D apps and desktop engagement, ultimately it will reside in virtual reality. So it's quite difficult to work out what user engagement is going to look like. Currently, virtual reality headset shipments are fairly low at the moment. Maybe that's due to post-COVID. And what we see is the number of social media users using them is not very high at the moment. That will probably change. We also know that different users may react differently to virtual reality. That could be down to health conditions, their personal preferences, and we need to consider things like the accommodation of the eye. Sometimes people get a bit seasick from headsets because of the accommodation in the eye is saying one thing, but the brain is saying something else. That causes a disconnect, and we can get a bit seasick. Sometimes not everyone is like that, but some people might be. So it really means we need to take these very human factors into account and offer people options as well, where they are in the metaverse, but can also have other options such as applications. Again, the data will be really important to make sure that we understand if we are using the metaverse or whether someone is preferring a more 2D way of interacting. And we need to cover both of those. But to do that, you need a good understanding of the customers. So what are the risks? Well, how are people going to pay? Somebody somewhere is going to pay for that. Now, crypto is still a new thing for many people. So again, building out that metaverse platform in your business, you're going to have to think about payment methods. So the shifting value of crypto can mean that people feel maybe that this adds in additional risk. Now, there will be a lot of business transactions taking place in the metaverse. Those will probably leverage blockchain, and they can do that through cryptocurrency perhaps, or non-fungible tokens, NFTs. Now, crypto is still spiking and going into troughs from day to day. Now, that means that the metaverse itself could potentially be at risk from economic instability, and investments in things like NFTs may not be as reliable as a real world trade. So that could deter customers. There's also some concerns over portability. We talk about cloud portability. Actually, I don't think any of the cloud vendors, the major ones, are that portable. But started off like that maybe, but we now see that they now are starting off with very cloud specific services on top of the platform. You could, for example, take data out of AWS and see it in Power BI in a Microsoft platform, but you'd have to pay for the egress of that data. So the portability is already a risk in the cloud, and that is something we need to consider when we're thinking about the metaverse. So What that means is for virtual reality is that virtual reality infrastructure may be difficult to translate between clouds, and it may also be difficult to translate into a brick and mortar office real world environment as well. So that could mean we might see something like we saw in the 1990s, where we had a big .com bubble. If you weren't around then, why don't you Bing search or Google search around for the .com bubble? You can see what happened. But basically, a lot of companies couldn't remain viable, so there was a lot of collapse. So metaverse native companies may not be viable in the long term either. We may see lots starting to spring up, then collapsing as well. Things will probably settle out over time, but just to be aware, you might see us reaching that trough of disillusionment where metaverse native companies do start to fail, and then we start to see things settling out again. So we need to think about decentralization as well. So if something is decentralized, which the metaverse will be, then it means it's often deregulated as well. So a true metaverse needs to be decentralized, but we do need some common ways in order to transfer data around. It means it won't be owned by anyone, and we need complete transparency and democratization, equal access as well. So that means it's hard to regulate anyway. So even if regulatory bodies come out with robust data protection policies, for example, it would be really hard to enforce those without trying to bypass that decentralized architecture for the metaverse. So that gives us a bit of a problem, and all of these problems are there to be solved. But the main thing is that having a good data platform, incorporating real data, real-time data, and setting yourself up for success with big data technologies will really help you to get a good platform in place so that you've started to think about all of these things as you go along for the metaverse. Just because you're not in it now doesn't mean you can't start to think about being metaverse ready. So just to have a recap, data is everything for the metaverse. So us as big data specialists, we're in a good place, okay? We just need to make sure our house is in order so that when it arrives, we're ready for it. It's an exciting time. It's going to be hard work. Now, if you've ever read Alice in Wonderland, you may have come across the Red Queen's race. And what this means is really that sometimes it will feel like it's all you can do to keep up with the technology, and that just seems to get us in the same place. But if you want to run somewhere else, then you need to run twice as fast as we are now. Sometimes feels that we can't keep up very well. The story in Alice in Wonderland is that Alice is running in the spot. She's not moving. And the Red Queen says to her in the Looking Glass, the book, the Red Queen says, if you want to get anywhere, you'll have to run twice as fast. And sometimes it was just going to be a matter of taking that risk and running, really, to try to keep up. But to do that, you'll give yourself such a better chance of succeeding if the data platform is in place. So if you can make that happen, you'll thank yourself later. So we know it's going to threaten traditional businesses. So please, if you can, think about getting the data in place, okay? Because if you can do that, then it will be so much easier. Another thing you can do really is think about what the metaverse, first of all, means for your customers. Maybe think about starting in-house initiatives first in order to get yourself through the bump of some of the things you're going to have to think about. It means that everyone in the business is pointing towards a roadmap of initiatives to get the data into good order. You can be the leader in your organization that puts this forward and puts a program in place. It means that everyone should be pointing in the same direction. There'll be some nuances, but it really means that you know that getting the data into shape is the right thing to do. It's the direction of travel. So, for example, if the data isn't clean, then you should think about doing a 360 to make sure that you understand the path of least resistance, how you can become more successful with the data. So in terms of your customers, think about what that means first of all, for your internal teams, maybe do some small projects internally first, and then work on more customer-facing ones. Think about what the competition are doing. Okay, so I would have a think about that. I'd also think about any opportunities that you see in the metaverse for your business as well. So be innovative and have that fail fast approach. And it allows you to be creative. For example, you might see ways of reducing costs and thinking about the data and solving those problems early on will hopefully help you see what challenges you might have further down the road, and you can start to deal with the technical debt as early as possible. You don't want to be still living in Excel spreadsheets when the rest of the world has moved on, because they are not going to stop the world from spinning while you try to jump on. Okay. So first of all, get that roadmap of initiatives and what that looks like for your business. Then think about what the metaverse is for your customer. What does it mean? Now, when customers sign up for your services, what they're doing is they're tending to think about a transaction. So they give you their data and they expect that you will understand who they are and that they have a personal relationship with you. So you've got the customer, you've got your business, and there's a transaction. The customer gives you their data, they accept your terms and conditions, and you give them a service or a product. But because they've given you their data, they're expecting their relationship to be much more personal with you. Customers are not just sensitive about cost. They're more thinking about what the data should be like to be meaningful. And they're thinking that they deserve a meaningful service from your business. So a really solid data foundation is so important to try and make sure that the company's got a good basis to start from. So that's really important. You should also expect to adapt as well. You're going to see more interest in analyzing data from the metaverse. So I would think about what tools you can use in order to help you to understand. It's not just enough to understand the data. It's about putting the data together to get insights from it. What is the data telling you when you start to put the things together? So businesses will start to need to adapt as advancements and opportunities start to appear. And also think about what you can do to make your life easier. So getting data quality sorted now, looking at technologies. If you're not collecting real-time data from anything, why not start just there? Start to think about real-time data and seeing how you can land that data and put it somewhere and see it on a report. Some businesses I work with are not collecting any real-time data. And it's a good way just to get started, collect something. And then that means that you've already started to understand the challenges better and translate those into solutions for your specific organization. Once you've done that, you can start to think about optimizing as well. And making a solution work, like a prototype, is fine, but very often we find that the prototypes become the real thing. So we have to think about the ways that actually we move it from being a prototype. So fail fast. Don't be frightened to say, this isn't working. Let's pivot and start again. Also good to be creative as well. You know, have fun with it. The metaverse can be such a great place for fun. And what we need to think about is using any pre-baked AI services just to get yourself up and running as well. So how can you get started? Get meta savvy, get familiar with the concepts, think about your data, get skills. Data fluency is so important. Understand your data well. Do that, and then you can start to build on it. And set up that Metaverse Center of Excellence. This was some advice on the Meta website. You can go and see and have a look at that. But having that Metaverse Center of Excellence really means having a data center of excellence, having an analytical center of excellence. All of these things together bring together the source of knowledge and skills in your team and try to think about getting the data right as early as possible. Set out a strategy. What's missing in your business? Are you running out of storage? You'd be surprised how many businesses I see that aren't really familiar. They do no capacity planning. And that means they don't know how much data they will have in a year, 5 years. They don't think about it. Think about data governance and compliance as well. And that's really important. Because if you're not compliant now, there's a risk that you're not. The problem's going to get worse. So these are great concepts, particularly to consider if you are looking to progress upwards in your career. Looking at compliance and data governance is a great way of doing that. It connects you with the leaders in the business. So that's a good piece of career advice. And you have to think about APIs, extensibility, and connectivity. How can you make these data systems talk to one another? Okay, so just end in a final quote. For those of you that are science fiction fans, you may already know William Gibson. The future is already here, and it's just not evenly distributed yet. And I agree with that. It's something that people are getting on board with it, and it can be accessible to you. Just get the data right, and things will follow on from there. And with that, I just want to say thank you very much for joining me today. Thank you to SoftServe and the team for looking after me so well. So thank you to Victoria here. She's not on the screen, but she looked after me really well. So I want to say thank you to her too. And if you get in touch with me, hello Data Relish. If you have any more questions, let me know. But with that,
Jennifer, thank you very much. That was an amazing presentation, and especially for me, right? Personally, I'm new to Metaverse concept, right? So that was an amazing presentation to at least start thinking in that direction. And probably we have a couple of questions, right? One from me and one from our audience. My question.
Yes.
You said the Metaverse should be decentralized thing, right? And that's like new future, right? Because centralized unit can be like very much a bottleneck for whole Metaverse. At the same time, do you think there should be some standards defined, or maybe like community defined standards, which everyone should follow? And do you know any of such movements already in the community to create some kind of standardization?
And so to answer the question, the first part, yes, I would love to see the technical community start to adopt or think about standards. I think there's maybe a few pots here and there, but I do think that it's something the community, particularly in open source, can start to own. I know that we think about the metaverse, people think about companies, but actually we see that there's so much great innovation coming from open source, and I'd like to see them more involved. So I think I remember with RFID, RFID tags.
Yeah.
It took 15 years, 15 years for people to settle on a standard. Humans are not very good at setting on standards. So
all right.
For the metaverse, I think it might be worse. So I think it is important.
It can be a good field for being creative, right?
Yes.
When you still don't have standards, so nothing limits you in what you're doing there.
That's right.
All
But it's
right,
quite
all right.
tough because you need to transfer data back and forth. So we are going to need standards, I think. So I think that's where the APIs will start to come in. It's not always too easy to extract data through APIs. Sometimes you only get so much data. So it's coming back to great data engineering principles again, like in the session just before mine, the gentleman there talked about that. Very important.
All right, and I put here one question from our audience, from Victoria. So, and Victoria asking, whether do you know like any good examples of companies who successfully used Metaverse together with artificial intelligence to show some great results?
Yes, I see the two things as separate. So in terms of the metaverse, I actually think the company to watch are Roblox. If anybody has got children, you're probably sick fed up with Roblox, but they're really setting up more of a metaverse environment. So I think we may see as kids start to get older, they've just grown up with Roblox and games that are using this technology, and we'll start to see it filter through. And I think that's really exciting. So in terms of businesses using AI, I know I've personally delivered AI solutions for people like finance organizations. AI has been around a long time, and I think the two things together will mean we'll see another surge of a progression in the industry, because I think to be really successful in the metaverse, you'll have to use AI, but you'll have to use it in different ways. So we'll have to try and automate as much as possible, and AI is so good at that. But I think also AI from gaming would be a great way of using that in the metaverse, trying to predict what people will do and what level people are at. So I know with some AI inspired in games, if you go in some online games, they're trying to work out what your level is. So they pair you with someone who's a similar level. You have a good experience. And I can see us using AI to identify customer profiles in the metaverse so we can work out which products to actively present to them. So.
Yeah, I guess the gaming industry companies are going to be the first ones jumping in metaverse, right? Because they have already technical skills to be there, right? At the same time, as you said, we need to combine that with meaningful data, right? So that we don't create new games, we create something useful for clients, for people, to make it popular.
That's true. I've been working with one robotics company using AI, and the purpose there is to try and identify in the environment weeds, and they are choking crops. And that's so important, and it's actually really hard to do. So I think it's not gaming is a large part of it, but I'm really hoping that it will trigger research into issues which everybody faces. So climate change just being one of those.
All right. All right. Thank you very much again, Jennifer. And that was pleasure to host you here and to have presentation from your side. And we're going to go to the next presentation. And Jennifer, have a great evening and see you hopefully next time.
Will do. Thank you so much for having me and for hosting this great conference. It's been really great, and I look forward to the next session too. I'll tune in for that.
All right. Cheers.
Thank you. Bye.
Bye-bye. All right, guys. And that was Jennifer. And right now we have another guest on our conference. And this person is great technician, having a lot of experience with data processing and being great engineer for many years and providing consulting services, being like CTO as a service. And our next guest is Tibi. Ran, adding you to the stream.
Thank you very much, Vitali. That's a great presentation for me.
All right, all right. So, and your presentation today is going to be about BigQuery and making data like safe in BigQuery, protecting it from, I don't know, from people which shouldn't have access to this data, right? It's like kind of...
Well, I will not say that it's about BigQuery because I'm not going to make a demonstration of the tool, but it's mainly about how to protect your data in BigQuery and how you can keep your data encrypted actually in BigQuery.
Yeah, it's a very important topic. And like before I start, right? So who should pay attention to this presentation, right? I mean, which maybe the domains or you know, people like from like data, like usual data engineers, right? Should they actually care about it?
So I would say, in short, I would say everybody should care about security. Everybody should care about how we protect our data or data pipelines. But I would say that everybody who deals with data, if you are a VP data, then you probably want to know what are the major principles. And if you are a data engineer, you should know how to implement it. And if you are a data analyst, you should know how to use it, but also understand why is it important. So everybody from different perspectives, if you are dealing with data, will probably want to understand what are the main principles in order to achieve such a secured and the different secured level of your data. Because we have a lot of data, and it includes sensitive data and personal identification, and the data is, I think that today is the most valuable thing of the companies. So if you don't protect it in the right way, then you might find yourself in like a cyber attack or even a leak. Even someone will make a mistake and you stop.
Fair enough. Great setting stage. So the stage is yours. Ron, you can proceed with your presentation.
Thank you, Vitaly. So my screen is shared right now. Yeah, cool. So you can see my screen right now, and like as I said before, I'm going to talk to you today not about BigQuery, but about encryption in BigQuery. And more than that, we are going to discuss about important principles in data pipeline protection. We will see how BigQuery provides such out-of-the-box tools in order to perform such tasks. Now, I really want to note that even if you don't use BigQuery as your data warehouse solution, you may still benefit from these talks, as you might get ideas about how to implement such principles in your own data platform. So stay with me. Vitaly already introduced me, but I want to introduce me in my way, okay? So I've been coding since I was very young, and I'm really passionate about technology. But I'm even more interested in how places without technologies live today. And although I'm going to talk to you a lot about bits and bytes, I generally try to be connected to my inner child and follow the philosophy of the Little Prince. Throughout my career, I've worked solely with startups, two of which I founded myself. One of them was in the field of farming management, and the other one was in the field of chronic pain prevention. For the last 2 years, I've been working as a contractor and offer CTO as a service for early stage startups and data engineering services. I have companies to achieve their business goals, to build their data architecture, build the data pipeline, design the data warehouse, and generally deal with any data or analytics problems that they have. So let's get started. I want to say that this talk is actually a result of a real use case that I did as a project for one of my clients, and we actually tried to find a way to protect the data there. And this talk is a result of this work. So if you ever built a data pipeline, it was probably looked as follows. You have an application which gets request in REST API, does some processing, and then loads it into your data warehouse solution. It might be BigQuery, maybe Snowflake, or maybe Redshift, or even Iceberg. And in other cases, you might decide to first load it into GCS and only then load it into BigQuery. Or GCS, stands for storage service, such as Google Storage or maybe S3. And in reality, you probably have more complex data pipeline, which first writes the data into some message brokers, such as PubSub, maybe Kafka, or SQS, and then another big data process the data, and only then loads it into GCS or BigQuery. But no matter how you decide to build your data pipeline, in the end, you have a file in your data storage service that looks as follows. In this case, it's a JSON file, but it might be a Parquet file or maybe Avro. And in your data warehouse, you have a tables a table that looks similar to the following example. You have the user table, which is table that has two fields, the ID and the email. And when you look at this table, you might consider some of the data here as sensitive, right? Like, let's think about email. Like, I guess we all agree that we don't want our user emails leaked. So when we look on our data pipeline, we probably want to protect it in few different levels. The first level is what we call encryption in transit. We would like to make sure that if someone listening to our network or sniffing our request, he won't be able to understand anything. And thankfully, this practice is provided by SSL. If you use SSL and you send all the requests in HTTPS, our data is seamlessly encrypted in transit, and happily, all GCS services, ChatServe, PubSub, GCS, BigQuery, are supported SSL by design. So when you use this platform, you only need to make sure that the other parts of the application, for example, are encrypted in transit. The next level is what we call encryption at rest. When we speak about encryption at rest, we would like to make sure that if someone is succeeding getting access to the physical hard disk in the server, like get into GCP data center, get the hard disk out from the server itself and try to read the data, you won't be able to retrieve any data from there. I mean, the entire file on the hard disk will be encrypted. Now, also in this case, PubSub, GCS, BigQuery, seamlessly encrypted at rest by design without any additional configuration. Actually, you cannot even choose to store the data there without not encrypted, like as far as I know. So, but even if we are protected in those two levels, once we have access to the table, then we can get the plain data and use it as we want, right? Like you got access to the table, you go to BigQuery UI, query what you want, and you got the data seamlessly, all right? So if someone succeeds in getting access to my computer, for example, then he can actually read the data. So that leads us to the last level, which is the application layer encryption. We would like that application to encrypt the sensitive data before it's written into PubSub, or at least before it's written into BigQuery. And then we will get our sensitive data, in this case the email, encrypted as follows. But you might say, right, but in some cases, I wish to be able to retrieve the plain data, right? And I wish to get some functions like a decrypt function that decrypt the data on demand on query time, if I have the permission to do so. So we have some functions that like select decrypt email, and then we got the decrypted email. And of course, if I have the right permission. Thanks to AAD functions, we have this ability. AAD functions are a list of built-in functions supported by BigQuery that mainly give us the capacity to encrypt data, decrypt data on demand in querying time, and it also supports creating keys in a straightforward and very simple way, and we are going to see it in a minute. So let's see how it looks. We use the functions, it's like a UDF, right? It's not a user-defined function, it's a built-in function, but we use the function deterministic decrypt strings, which gets three parameters: key set, which is the encryption key; email, which is the encrypted, the field that we want to encrypt, like in our case is the email. And the last parameter is associated data, which we are not covered today. It just makes things much more complex. You can read about it after it. And using the key, BigQuery decrypts the data and returns the only decrypt on query time. So that's exactly what we wish to get, right? Like we have the function decrypt and we store the data encrypted, and now we can decrypt it on demand as long as we have the encryption key. So you might think, all right, so we can actually finish this presentation, go home. But yeah, I guess like at least some of you say, yeah, but Now it's mean that everybody has to have access to has to store the encryption key in order to get access to the data. And that means that all the analysts will store the key on their computer. And this is something that probably we want to avoid. Now, let's assume for a moment that we are okay with this approach. We are okay with spread the key around to all the users in the organization. Even if the query, even in this case, when we execute this query, it's going to be written to the log, which means that if someone succeeds in getting access to the log, he will find the key there. Yeah, like, so you understand that this is very problematic to use this approach. And so if the encryption key is top secret, and we probably want to protect it, we all agree about it, and we use encryption in order to protect our data, maybe we can use the same approach, I mean encryption, in order to protect our encryption key. So I'm going to show you the following practice. This is how it looks. We're going to use two different keys. The first key is the data encryption key. It's also called the DEC. This is the same key that we want. It's the key that's going to encrypt the data. And we use another key, which is the key encryption key, which is the DEC. We will use it in order to encrypt the DEC, and then we get an encrypted DEC, which is the wrapper. The wrapper is completely gibberish. It's not sensitive, and we don't need to worry about protecting it. We can even commit it to Git, since it only can be decrypted using the cake. So we encrypt the DEC using the cake and gets the wrapper. The wrapper is completely not secured, not sensitive, and you can just do it whatever you want and spread it around. Let's continue. And from the application perspective, and if we want to encrypt or decrypt data, so once the application starts, it gets the wrapper, decrypts it using the cake, and gets the DEC. At this point, the application has the DEC in the memory and can decrypt or encrypt data as usual. But you probably ask yourself, yeah, but what about the cake, right? Like, didn't we stay with the same problem, since now we have to protect the cake? Like, we won't get another encryption key or another encryption key, and etc. Right? So the solution is probably that we want to have some external service that will hold and protect the cake, and will decrypt the wrapper on request. And that's exactly what Google KMS does. Google KMS, Key Management Service, is a service that supports three main functionalities, a Google service, all right? That supports three main functionalities. Create and store keys that we will use in order to create our key. And encrypt and decrypt functionality that we will use in order to encrypt the DEC or decrypt the wrapper later. What Google KMS doesn't support by design is exporting the key. That means that if we create the cake using Google KMS, we will be able to decrypt our wrapper or encrypt our cake, our DEC, but we won't be able to export the cake itself. So the cake is safe, secure, unreachable even to the cake creator. Like, even if you create the cake by yourself, like go to the UI of KMS, create the cake, you won't be able to extract it from there, so it's completely safe. Now, here is how the wrapper creation process looks when we use Google KMS. First, we create the cake in KMS, and then we create the DEC as we did before, and ask KMS to encrypt the DEC using the cake. If we have the right permission, then KMS will return the wrapper to us. Once we have the wrapper, we can now look how the encryption process looks. So the application gets the wrapper. Sorry about that. The application gets the wrapper and sends the wrappers to KMS, including the URI to the cake, not the cake itself, because it doesn't hold it. And if the application has the the right permission. Then Google KMS will decrypt the DEC and will return will decrypt the wrapper using the KEK and will return the DEC to the application. And in this moment, the application has the DEC in the memory, and it can decrypt or encrypt data as we did before. All right. So it's time to see some coding. All right. So allow me to note, you don't need to worry about remember anything, copy, or taking screenshot. In the end of the talk, I will send you a link to a blog post with a step-by-step instruction. So for the moment, just follow me and get the ideas of how to implement it. So as we said, the first thing that we would like to do is to create the cake in KMS. We can do it easily in a few clicks in the UI, or we can do it in the CLI. The first thing that we should do is create keyring, which is a group of keys, and then we create the cake in this keyring. At the end of the process, we will have the URI to our cake. Once we have the URI to our cake, we can use it in order to create our wrapper. We will use another AEAD function, which is keys.new wrapped key set, which gets two parameters, the URI to the cake and the type of key that we want to create. BigQuery will create a new DEC under the hood. All right, we won't create the DEC by ourselves. BigQuery will create it under the hood. We'll send it to KMS and we'll request to encrypt it using the cake. The result of this process will be a wrapper which looks like this. As you can see, it's a gibberish. It's not sensitive. And notice that we never saw the DEC itself. We only get the encrypted DEC, and we are welcome to spread this wrapper around, commit it everywhere, because only someone who has permission to the cake in KMS will be able to actually decrypt it and get the DEC itself. Now, let's assume for a moment that we have encrypted data in the table, encrypted by this DEC. We will get in a moment to understand how we encrypt the data and put it into BigQuery, but let's assume that it's there. So now we want to decrypt the data. We will use the same function, which is deterministic decrypt string. But instead of providing the actual DEC, the actual encryption key, we will use another function, which is keys.keysetChain, which gets two parameters. Surprise, the URI to the cake and the wrapper. In process time, only once in query lifetime, and not for every email, right? Like only once in the beginning of the query. BigQuery will ask KMS to decrypt the wrapper using the cake, and if the user has the right permission, KMS will return the DEC to BigQuery. BigQuery will use the DEC in order to decrypt the data and discard the DEC, and the DEC itself will never be returned to the user. So we got a decrypted email, but we wasn't able to retrieve the DEC itself. So that you can see how secure it is. Now, when we look on it, we might say, that's cool, but it's very complex, right? Like, it's multi-statement, and I have to write all this bunch of code in order to decrypt the data. Like, very complex. I wish to have something more simple, I would say. So in order to solve it, what we did is just create a UDF. We called it decrypt, and we hide or wrapped all this functionality in a single function. As you can see, we put the call to deterministic decrypt string here and key.keysetChain, and also the wrapper and the URI to the cake. And once we got it, we can just do select decrypt email and get the decrypted email. So of course we need the right permission to do so, but like this is exactly what we wish for. We have a function, select decrypt, and we can decrypt the data. Cool. So now let's take a moment to talk about permission, because I always say if the user has the right permission. All right, so let's take a moment to discuss about it. So when we create a cake in KMS, we have two different kinds of access role. The first role is what we call encryptor-decryptor role. If the user is assigned to this role, that means that he can ask KMS to decrypt the wrapper and reveal the plain deck. And this is exactly what we want to avoid. And for that reason, GCP created very cool rule, which is decryptor via validation. When a user is assigned to this role, he cannot decrypt the wrapper by himself, but he can delegate the permission to another GCP service, such as BigQuery. BigQuery, in this case, will ask KMS to decrypt the wrapper on runtime, use the deck to decrypt the data, and then discard the deck. So in this case, the data will be decrypted, but the deck will stay secure, and the user will never have access to it. So therefore, all human users should be assigned to decryptor via delegation only, and no one should ever be assigned to decryptor role. Keep it in mind. Now, I can't stress it enough, guys. The deck was never revealed to any user during this process, even when we created the wrapper. All right, so do you understand how significant is that? So we spoke a lot about how to decrypt data in BigQuery, but first we should encrypt it somehow. I decrypt, but how can I encrypt it, right? So we probably want to do it on the application side before we load it into BigQuery. And in order to do it, we can use the Think library. It's an open source library developed by Google that makes dealing with keys and encryption very simple. It has a version in Python, but also a version in Java. Here you can see the Python version. The Java version is also very easy. Let's see how it works. The first thing we should do, of course, is to decrypt the wrapper. So we use the function keyset handle .read, which gets surprise the wrapper and the URI to the cake. Think in this case, if the application has the right permission, we'll ask KMS to decrypt the wrapper using the URI to the cake. And if the application, and then it will return, and then in this case, we will have the deck in the memory. We can create with it a cipher object and encrypt and decrypt the data. Like, as you can see, we did all the requests from KMS and etc. was hidden by this functionality of Think library. Now, notice that once we create the cipher object, it holds the deck in the memory, which means that any individual that will have access to the server, they will be able to retrieve the deck. And therefore, it's important to say that you should restrict access to the server and make sure that any maintenance will apply from outside, like using CI or logs, but no one should ever have access to the server, because the server, in order to ask KMS to decrypt the wrapper, it needs to be it needs to assign to decrypt the role, all right? Like we said before, like decrypt the role means that we can actually get the deck itself. So keep it in mind and make sure that all the maintenance is applied from outside. Now, as you can see, it's simple, and like in just few lines of code, you can start encrypting using the cake deck wrapper approach. Another option is to encrypt the data in BigQuery. Much like as we use the deterministic decrypt, then now we can use deterministic encrypt, and it will encrypt the data. You will probably want to use this functionality when you are modeling. Like, for example, if you create a model that extracts the username from the email, you will first use deterministic decrypt to decrypt the email, extract the user from the email, and then use deterministic encrypt in order to encrypt the username. So it's less common, but you might still want to use it. And that's it. Our pipeline is now protected on all the 3 levels and also on the application layer. So we make a long way so far. And let's cover few more things. Let's take a moment to talk about deterministic and non-deterministic encryption. Like you saw that along all the way, all my example was about deterministic encryption, but BigQuery supports the equivalent functionality also for non-deterministic encryption. What is the difference between deterministic and non-deterministic encryption? Deterministic means that no matter how many times you will encrypt the data, you encrypt the same data, for example, the email aa@aa.com, with the same key, you will get the same gibberish. While in non-deterministic, you will get different gibberish every time, even for the same email. When we use deterministic encryption, we can still get some insight about the data, even if we don't decrypt it. For example, we can select the count of distinct emails without decrypting the data. On the other hand, if we use the non-deterministic encryption, you cannot infer anything from the encrypted data. Now, the decision regarding what to choose is pretty much depend on the use case, and you will need to think about it and determine the preferred method. But don't think that deterministic is less secure than non-deterministic all the time, because, for example, if you can get all your insights without decrypting the data, so you can actually show some dashboard and etc. without the need to actually call decrypt. So the data most of the time keep encrypted and secure. So in some cases, non-deterministic is more secure, and in some other cases, deterministic is more secure. So it's pretty much depend on the use case, and keep it in mind. Now, what about performance? Like, we cannot give such talk without talking about performance, right? So let's try to figure out what is the efficiency of decrypt functions. I won't say it was easy. But in order to do so, I created a table of 1 million records with 64 random bytes, encrypt them, and run the same query that will decrypt them all. In order to make sure that we actually scanned all the data, I tried two different queries, one with substring and group by, and the second one with select distinct. And I ran the same query, once on the plain text and once I called decrypt first on the encrypted data. As you can see, the elapsed time, all right, which is the actual query time, meaning the time that it took to the query to return, it's almost the same, like no difference almost. But when we look on the slots time, which is the amount of resources that the query used, we see overhead of 50 to 80%, and like that's a lot. Like as you know, BigQuery use more slots in order to execute more complex queries, but it depends on the general load and the ability of the resource, and we cannot guarantee that the elapsed time will remain the same. Also, if you run more complex queries, then your query might be slower. And anyhow, in my opinion, 100 million records in 22 seconds is super fast and super impressive. But still, a good reason to encrypt only the data that is really sensitive and not encrypt everything. Okay, only what is really sensitive. What about pricing? So regarding pricing, we should consider a few things. As you remember, the method keys.keysetChain, which actually decrypt the wrapper by calling KMS, called only once in query processing time, not for every, like only once, on like the query start, and then we call KMS in order to decrypt the wrapper. So it means that we charge only for a single decrypt call, which is nothing compared to the query cost, since KMS charges for 0.03 US dollar per 10,000 decrypt requests. Okay, so it's insignificant. Okay, but that's a big but. You should aware that in each encryption field we have an overhead of 21 bytes, no matter what was the original value is. Like the length of the original value is, okay? Like firstly, that affects the storage cost, but more importantly, it affects the query cost. Why? Because since BigQuery charges per scan bytes, and now we are scanning more bytes. Like for example, if the average size of the plain field was 10 bytes, and now we have an average of 21 bytes, then we triple our storage, but also triple our cost, like a query cost, okay? Like when we query this table, we query 3 times more bytes, so the cost is 3 times more. And that's another good reason to keep in mind why you should encrypt only the data that is really sensitive. Last point before we finish, unfortunately, this mechanism has some limitation when it's come to multi-tenancy. As you remember, we said that keys.keysChain calls only once on query lifetime, which means that we cannot hold the table like tenants wrappers and use it dynamically, okay? So we can still encrypt any tenant with different wrapper and decrypt single tenant in BigQuery, but if we won't be able to do something like select decrypt all and join in order to understand what is the encryption wrapper or encryption key, all right? So this is some limitation that this mechanism has. And that's it. We got to the end of this talk. My main message for you is to keep data security in mind. Think about protecting your sensitive data. You already know the principle now, and you saw how BigQuery makes it easy to implement. But I would like to ask you to do it only when it's actually needed. Don't encrypt everything. Encrypt only what's actually required. Think about the analyst that's using the table and think how annoying it will be to call decrypt on any field, like select decrypt, select decrypt, select decrypt, it will get crazy. And if you will do it and you will encrypt everything, people will start save a decrypted version of the data, and this is something that you definitely want to avoid. Thank you very much for listening. I hope you enjoyed this talk. I was excited to be here. As I promised, you have a barcode here that directs you to the blog that I wrote. It includes step-by-step instruction. You can just follow it and implement it on your side. You are welcome to follow me on Medium, add me to your LinkedIn network, and also reach out regarding any data problems via email. Thank you very much. Are there any questions?
Yeah, Ron, thank you very much for your presentation. That was like a very sophisticated way to make sure your data is encrypted, right? And we actually have some questions here, right? Let me put it on the screen. And the question is from an account called SQL UA. And the question is about like, if we encrypt data client side, right, and send data then to BigQuery. The question is about how we can operate with data, like doing some complex operations like joining. Like I assume the question was about like if the join key is encrypted itself, right? So without encryption, like probably this is about like deterministic.
Yeah, so I think that the question is that can I join using the encrypted data and BigQuery will decrypt the data under the hood for me and make the join? So the answer is no. You have to call decrypt before you're doing it. But actually, if you need to join, only the encrypted field itself it's bytes, or you can save it as string. So you can join by this string itself, okay, if you need. So now it's actually very complex to me to understand the specific use case when you will actually need it, because most of the time the fields that you actually need to join on is not a PII or something that you prefer not to encrypt from the beginning. This is something I always repeat about. Don't encrypt everything. Encrypt only something that is actually sensitive. So
at the same time, right?
You need to make the join. Then you will have to probably decrypt the data, and then but then anyhow you want to decrypt the data, I guess. So it doesn't matter.
Yeah, and actually that's a good advice, not to use PII data as your key in the table, right? So
Right.
be careful about choosing the right key. But at the same time, right? Like let's imagine we need to join, but like some
By
another
email, for
data
example.
or filter or whatever, right? Doing some operation, and that's actually like you mentioned. If you use deterministic decryption, right? It means you potentially can join, right? Because
Yeah,
you know,
nothing stop you. This is one of the advantage of using deterministic encryption. Like for example, you can know that this email is a specific email that you are going to query on, and you can just provide the encrypted field, the encrypted gibberish, all right? Like the encrypted the email, and you don't actually need to decrypt before you query. You can just use the encryption data in order to perform it.
yeah, exactly. And guys, like I think it's a wise advice, right? About being careful and reasonable about what you're doing, what you're encrypting, what not, because everything is a trade-off between, let's say, protection of your data and convenience of using it, right? And in this case, like we are choosing what is more important, what is your use case, and whether like the data is so sensitive you need to protect it this way, or maybe you can sacrifice security towards usability, right? So it's actually design decision you need to make as an architect if you design the data schema for your use case, right?
And also keep in mind that anyhow it's encrypted. Yeah, like the data in BigQuery is encrypted in transit. It's stored securely on the disk. Like we are talking about a situation that someone will succeed in getting access to my account with my permission, and then go to BigQuery and will decrypt the data this way from the front door, not from the back door.
Cool. All right, I see we have no additional questions here. So let me thank you one more time
Thank you
and
very much.
being like so positive during this presentation and giving a lot of insights and experience working with BigQuery and encryption of data, both on client side and BigQuery side. Thank you. And now we are going to have our next speaker, and this is an honor to introduce you Ralph Richards, who is solutions architect at AWS, and Ralph day by day working with many different clients of AWS, helping them to define architecture and create solutions. So Ralph, how are you doing today?
Brilliant. Thank you. Yeah, I'm doing good. Thank you. Nice to see you. How are you doing?
All right. And yes, then I guess like at your position, you have a lot of clients, and thank you very much for finding a time to join today and speak about very interesting topic, right? So today you're going to talk about low code in data and analytics, right? So like, is it right? So like, is it an attempt to make data solutions cheaper for your clients, right? Or this is a way to, find a workaround when people don't have right skills in the team, like to do data analytics manually.
Yeah, exactly. It's about kind of democratizing and allowing more people, more organizations who don't necessarily have all of the resources that big companies do to kind of unlock their data and get insight. A lot of them don't have, people with the skills to write Spark and PySpark and SQL. So this is about the tools that we have that will allow you to do data engineering in a low or no code manner.
Nice. Sounds interesting. All right. Well, all waiting for hearing more from you.
Brilliant. Thank you. Fantastic. So As I mentioned, I'm a solution architect at AWS. My name is Ralph Richards. It's a real pleasure to be here. And I've been at AWS for 2 years and 6 months. And before that, I was a data engineer. So today's discussion is about how you can simplify data engineering with AWS, in particular one service called Glue, which I'll talk about in a bit more detail. But the main outcomes for the session are really to kind of understand what data engineering options are available on AWS from a low or no code and serverless perspective. So I'll cover the benefits of each of these, and then I'll introduce them into an architecture and discuss the technical challenges that they solve. But before I go into that, I want to pose you a question. And if somebody is lost at sea on a raft and they've been lost for, let's say, 4 days, and finally someone spots them and a ship comes out to rescue them, what would be the first thing that they want when rescued? What would they be desperate for? And the answer probably, most likely, is going to be drinking water. And that's really ironic because this person has been surrounded by nothing but water for days, but it wasn't consumable. And this is the situation that we're trying to solve with Glue and a lot of the data engineering services that we have on AWS. This is a situation that lots of companies have where they've got lots of data, they're surrounded by data, but it's not consumable. So if they have all this data and they want to consume it, then they go and hire data engineers. And these are obviously responsible for the data infrastructure, the data collection, the management, the transformation, and the access. And they're the people who are in charge of creating pipelines that convert the raw data into usable formats for the data scientists and for other consumers to use. I'm going to focus today's presentation on an example company that I've just made up. So it's called Example Corp. It bears no resemblance to any real company. So if there is a company that you know of called Example Corp, then this is not it. It's relatively small. It has, let's say, 130 employees, and they offer a product to their customers, the successful SaaS product. And due to the way it's architected, they've gone for the siloed approach. So each of their customers has their own separate deployment and a separate relational database. So you can see here, I've just done the architecture for 3 example customers, and each have their own API, their own set of compute instances, and most importantly, their own relational database. Our Example Corp has a problem, and that is that they don't have visibility into each of the individual customers' databases. So if they want to gain insight into what's going on across customers, then they would currently have to log into each customer environment, connect to each relational database one by one, and then run queries on that, and then combine the results with all of the others. But what they really want to do is bring all of this data together, combine it with other sources, and put it into a data warehouse. So Example Corp essentially need to perform ETL, extract, transform, load, which means extracting the data from each of the independent relational databases, transforming it in a way that can be used for analytics, and then loading it into a data warehouse where it can be used by the business to make decisions. And normally for organizations to make their data consumable, to turn that sea into useful drinking water, they tend to hire these people. So these are different personas that kind of exist that organizations look to hire. And you can see data engineers up there. So data engineers, as I mentioned, are responsible for creating the pipeline that this data travels through, from input to storage to transformation, all the way through to usable information. And these data engineers often need to know Python, they need to know Scala, they need to learn multiple tools, they need to know multiple database systems, maybe one for stream processing, one for batch processing, and there are all these different tools and systems and products that they need to learn. But Example Corp is small and they have limited technical capabilities. They don't actually have data engineers working for them. They're just a small team of developers and they're not specialized in data at all. So one of this team will have to become a data engineer. And this is pretty common. There are lots of cases where organizations and companies who have ambitions to plug their data together to gain insights just don't have the in-house expertise. They could go out and hire some data engineers, but data engineers are unicorns. These skills are really hard to hire for, and not every organization can afford to. So in our example Corp simply can't afford a data engineer. And if they could, they couldn't afford to go through the lengthy process of hiring and onboarding one. So instead, Example Corp turn to solutions, and they start to research if there are any tools that they can use to do ETL with their existing team. One of their existing team members can perhaps upskill and do this ETL. The thing is that data preparation is kind of tedious. It's very complicated, and Example Corp's engineering team don't actually have the skill set or the bandwidth to do this. Some industry estimates have actually indicated that in certain analytics and machine learning pipelines, up to 80% of the time is spent on data preparation activities. So this is a really time-consuming, often manual, inefficient, and expensive task to perform. When Example Corp go and look at the market at traditional ETL solutions and products, they might find that they need multiple different solutions to fit together to get the overall job done. And they might also see that some of these tools are not particularly scalable. They're quite complex to install and manage, and they would need to go and set up infrastructure and manage servers to run these tools on, which is definitely something they don't want to spend resources doing. These traditional solutions often also come with high costs in the form of licenses. And again, Example Corp don't have the human resources to dedicate to learn how to use these traditional solutions. Now, there's a phrase that they've heard of that's been growing in popularity over the last 5 or so years, and that's the phrase low code. And this kind of first emerged around 2016. Sometimes it's referred to as no code or low code, and it's a general phrase for development platforms and tools that are designed to help business users develop applications without conventional software development. So these things often use a drag and drop interface. They're visual modeling with building blocks, and it's much simpler to use a visual modeling user interface like this to build an application than it is to write hundreds of lines of code. So the idea with no code is that anybody in your organization can design and create business applications without the need for specialized coding skills. So Example Corp come across this phrase and they think that's exactly what we need. We don't have the skill set for data engineering, and our people don't know PySpark. So we need no or low code ETL. But we also want a solution that can be used by data engineers in the future. If we do expand, we do grow, we do get that skill set. We don't want to limit ourselves by using a basic tool that we can have to replace in the future if we end up getting that in-house expertise. So through this realization, Example Corp could be introduced to AWS Glue. This is a service that AWS offers. It's a serverless data integration tool that makes it easy to discover, prepare, and combine your data for analytics, for machine learning, and for application development. So it provides all the capabilities that are needed for data integration, and it allows lots of our customers to start analyzing their data within minutes instead of the months that they would need if they went an alternative route. One of the key benefits of Glue is that it's serverless, so there's no infrastructure to maintain. You just run your jobs and AWS will take care of the rest. And it's also catered to different skill sets. So it's designed for everybody from advanced data engineers who can write complex code, all the way to those who prefer no code and want a drag and drop interface. So it's not targeted at any one particular persona. I'm going to dive into some of the various components within Glue. So the very first step of your data integration is to discover and connect all of your data sources. And for this step, Glue offers a rich ecosystem of connectors. So you can see on the left, you can select connectors for your specific data source, whether they're on-prem or in the cloud. It could be a relational database in RDS, or even streaming data like Kafka or Kinesis coming in. And once you've connected to your data sources, you're ready to explore your data. So at that point, you may need more information on the schema of your data sources. And one of the most important activities during data integration is cataloging the data. And this enables you to work with the data easily using various services in the future. So this is where Glue crawlers come into the picture. And these crawlers will help in discovering your schema in an automated fashion and cataloging your data. Once you've connected your source and cataloged the data, you're now ready to do various transformations and data prep using whichever tool you choose that is suitable for your team. And once you have the data transformed, next up comes the consumption. And so Glue helps by directly loading data into various data stores like a data lake running on S3 or a data warehouse on Amazon Redshift or any other relational database, JDBC source or OpenSearch, anything where you would want this data to end up for analysis. And I talked about the various workloads that it can handle. So for example, if you have data that's coming in Apache Kafka or managed streaming for Apache Kafka, or it could be from Amazon Kinesis, which is our native service for stream processing. But in all of these cases, Glue can easily connect or tap into that data, so you don't have to use a different tool for stream processing. And it's the same case for batch. So if you have batch files or databases that you want to connect to and run batch processes on, then it can easily connect and work with these. It's not a separate tool to the one that you're using for stream processing. And one of the key benefits for Example Corp are some of the interfaces that it has. So these are some of the different kind of interfaces that exist within Glue. The first one is called Glue Studio. And if you're a data engineer who prefers visual development, so low code development, where you can drag and drop nodes into the canvas and kind of connect them for your data prep, this is where Glue Studio comes in. And I'll talk about this in more detail with a few kind of examples in a few slides. For those team members, those teams in your company who prefer a code-based experience, like a notebook, where they might want to go and run some Spark code or Spark SQL interactively, that's where Glue notebooks come in. And a third persona that may exist within a company is a data analyst. And you might have data analysts who prefer a no-code experience, but they want to do the data prep by themselves. This is where Glue Data Brew comes into the picture. And again, I'll cover this in a lot more detail shortly. But before we go into those in more detail, I just wanted to highlight, kind of loop back and say, we've seen the different interfaces that come with Glue and how they map to different personas. So I really wanted to highlight that this is one tool that kind of serves all the different personas that are involved in the data project. It's not targeted just at one particular persona. So how can Example Corp use AWS Glue for the extraction phase of the ETL pipeline? In order to extract that data from the three separate relational databases and combine it into one place, they could use AWS Glue Studio. And this gives them a graphical interface to create, run, and monitor ETL jobs. So as you can see through the screenshot I've got, you can compose the workflow and then run it on a serverless ETL engine, which is the AWS Glue Apache Spark-based serverless ETL engine. So essentially, you're creating Spark jobs without coding Spark. Now, there are so many transformations or functions that come with Glue Studio out of the box. So you've got transformations like selecting fields, dropping fields, deduplicating, joining, unioning, filtering, aggregating, all of these kind of out-of-the-box functions that come with Glue Studio that you can just drag on to the canvas and connect to the data sources, as you can see in the screenshot. In some cases, that may not suffice, and you may have very specific logic that you want to put in that's not supported or not available. So you've got the option for flexible transforms, which gives you the ability to write a custom transformation just for that piece where you have specific logic and add it on to the rest of the things that you have. And there are some activities that are very difficult to code or identify what steps need to be performed, like detecting PII or filling missing values and detecting duplicates and so on. And for these activities, Glue provides machine learning based transformations that you can take out of the box and take the benefits from just by dragging them onto that canvas. Now, I mentioned sensitive data detection. So let's just zoom in on this for a quick second, because there's a really cool feature of Glue that is being used more and more. And that's because a lot of businesses struggle to identify sensitive information in their data. So names or medical information or tax ID codes. So finding this sensitive data within your data lake is kind of like finding a needle in a haystack, where that haystack is just doubling in size, every day. So Glue gives you a capability to detect sensitive data. So it will help you identify sensitive data while it's still in your pipeline. So you can prevent that data from actually landing in the data lake. You catch it while it's still in the pipeline. And it can pinpoint the locations of sensitive data that has already made it through to your data lake. And you can go ahead and delete or redact it, or limit the access to that data to trusted consumers, but not everybody within the organization. So finding sensitive data has really never been more cost effective. And speaking about cost effectiveness, I want to touch on how AWS Glue actually helps you save money when you're running your ETL jobs. So if we start with a base case scenario, you've got a job running and you've allocated N workers for that job, and it's running for a specific duration. First thing to note is that the billing will stop immediately after execution of the job. So you're only being billed during the time of the execution and for the number of workers that you selected. For most organizations, traditionally, they would have to spend money on infrastructure, and they have a window where the batch jobs are running, and for the rest of the time, that infrastructure is sitting idle. So with Glue jobs, you don't need to spend money on infrastructure when your batch jobs are not running. And with auto scaling, I'm going to walk through this. Maybe I have 3 different operations within my job. So the first one could be a list operation where I don't need all the compute. So at that point, Glue will kind of scale down the compute. And once this is done, the next transformation in my pipeline could be a wide transform. So here it's going to need a lot more compute so it can scale up. And further down the line, it's possible you might do uneven data distribution. So some of the compute may be idle, and again, Glue will scale down. So what that means is everything in yellow is a potential cost saving with auto scaling because it's unused capacity that you won't be charged for. So that's how Glue makes it really cost effective. I mentioned a term earlier that I'd like to explain as well. So I mentioned the Glue data catalog. And this is a key feature of Glue. And once you've added your data to the data catalog, it's basically a central place that makes it really easily available for the various tools that you have. So, for example, it could be a data warehouse query, or it could be big data processing that you're doing using EMR, or maybe a machine learning model that you're running with SageMaker. If any of these, the data catalog will be a central place where you go and discover and search across your data landscape. So you don't have to move the data when you're doing this. So you've got automated schema discovery and management, and it really makes your data truly consumable to those who you give access to. Coming back to the Glue Studio interface, just zoomed into that screenshot a little bit more. So you can see here how I've dragged and dropped these external data sources on at the top. I've just got 2 examples here. So I've got a Kinesis stream and a relational database. And then I've dragged and dropped some transformations. So I've got a join, I've got a custom transform to fill in some missing values. And then I've got a selection transform to kind of filter it down. And essentially, without writing any code, users of all experience can take advantage of big data and build this pipeline. And for those of you who love code or enjoy code, you can access the job code via the scripts tab. So you can see at the top, you've got visual script, job details. The script tab will actually bring up the code that is generated by the editor as you drag and drop things on. And this actually means there's no lock-in. So when you use Glue to develop ETL pipelines, you get the scripts. And these are open source Spark SQL, PySpark, and Scala scripts. So the visual editor gives you the scripts that it generates, and you can take these and you can run them anywhere you like. So it doesn't have to be run within Glue, and that means it's completely open. So coming back to Example Corp, without writing a single line of code, we have done this. We've used Glue Studio to author a Spark job, and that connects to each relational database, extracts the data, combines them together, performs some transformations, and loads them into an S3 bucket. And that S3 bucket has got the result of that extraction pipeline with all of the data combined and various transformations done on it too. We could also have included some other data sources like analytics, clickstream data, other kind of relational databases that are not necessarily customer environments, anything that could potentially enrich this. But for simplicity, I'm just going to keep it with these 3 relational databases. So coming back to the ETL pipeline that we're building, what we've just seen fits here into Extract. So Glue Studio will run the job to gather data from our sources. It will union the databases together. Some of the transformations might be adding a unique customer ID so that the data, so that, you know, we can, even though the data has been unioned, we can still differentiate it by customer, performing some transformations and loading it into an S3 bucket. But remember that we might have extracted this data and done some joins, but this data is still mainly in its OLTP format. So it's mainly still optimized for transactions. And the next step would be to transform the data. So we might want to roll it up, perform some pre-aggregations, build some data cubes. We might want to change the way that the data is structured so that it's more friendly to run large-scale analytical queries on. Normally, to prepare this data for analytics and get it into an OLAP format, data scientists and analysts, typically, they use spreadsheets to explore and experiment with the data, or they rely on data engineers to transform the data into the required format. And this often delays the process for weeks or months. And customers can spend up to 80% of their time on this data preparation task, rather than actually analyzing the data and getting value from it. So out of all the work required, data preparation accounts for about 80% of it. So it's a huge component. We've already done the second biggest part, which is in orange, which is collecting the data sets. But the biggest part is cleaning and organizing the data, preparing the data. And for this part of the pipeline, Example Corp can go and use AWS Glue Data Brew. And this is an interface within Glue that makes it easy for data scientists and data analysts to clean and normalize the data with just a visual interface. And this can help reduce the time that it actually takes to prepare data by up to 80%. In Glue Data Brew, you can choose from 250 built-in transformations, more than 250. I think it's more than 300 now. It just keeps growing like everything in AWS. You can choose from over, I think, 300 built-in transformations to combine, pivot, transpose the data without writing any code. And then you can just point and click, and you can save these as something called a recipe. And then when you have a recipe, you can publish this, or you can reuse it on the full data set or on any other data set that is similar to the one that you're working with. And this is basically a reusable transformation that you can apply over and over again. And Glue Data Brew will also automatically recommend transformations to you. So this could be, it could spot some anomalies, and it could recommend that you filter these anomalies. It might recommend that you correct invalid or incorrectly classified data. It might automatically find duplicate data and suggest to you that you deduplicate it. Maybe it's recommending that you normalize data to standard date and time values, or maybe it's suggesting that you generate aggregates for analysis. And these are all transformations that it recommends for you, and then you can go ahead and perform just with point and click. One of the things you can do is actually automate the data cleaning and the normalization task, and then you can save this transformation step so that any new data that comes in is automatically applied to. And then you can evaluate the quality of your data by profiling it. And this will help you understand the data patterns and any anomalies that exist. And again, all without writing a single line of code, and all without all without managing any infrastructure. Glue Data Brew's sources can be pretty much anything. So it could be a data lake, could be local files, could be a data warehouse like Amazon Redshift, RDS databases, or many external sources. But once you've connected to a data source within Data Brew, you then select the data, build recipes, and schedule them to run. And from here, you can use outputs to gain insights. You can use it in your reporting or as input into a machine learning model. Coming back to see what it looks like in the console, this is what profiling your data looks like. So profiling your data lets you kind of evaluate the quality of your data, and you can understand the data patterns and see what anomalies exist. And you can run a profile job, which basically runs a series of evaluations on your data set and outputs the results into a report that you can then see. And this really helps you kind of understand and decide what kind of data preparation steps you might then want to go ahead and run. The second kind of screenshot I've got is showing you how you would clean and normalize your data with Data Brew. So as I mentioned, you can choose from over 300 built-in transformations to visualize, clean, normalize your data. And you've got a sample of the data shown to you, so you can see in real time the results of these transformations. You can also visually map the lineage of your data. So if you want to understand the various sources of data and the transformation steps that data has been through in kind of a single pane of glass that shows you from a bird's eye view this map, then Data Brew will help you to map that data lineage. And all of this can be automated. So you can automate data cleaning, and you can automate the normalization tasks by just applying these saved transformations directly to new data. So where are we at? Without writing a single line of code, Example Corp has done this. They've used Glue Studio to author a Spark job that connects to each relational database, extracts the data, combines them together, performs some transformations, and loads it into an S3 bucket. And this S3 bucket, we can call it maybe raw data because it's not yet been transformed. So then we've authored a Glue Data Brew job to connect to that S3 bucket and perform transformations on that data, and then put that final transformed data into a second S3 bucket. So in the transformation phase, this is what we've done. We've used AWS Glue Data Brew to transform our data, again, without writing any code or running any servers. And the only phase we haven't yet covered is the load and visualize phase. And what we do here really depends on what we want to do with our data. So if you remember from earlier, Example Corp had these requirements. They wanted to gain insight across all of their customers, which essentially we've done by joining all the different databases. They wanted to build business intelligence dashboards on top of that data, and they want to perform machine learning on that data. One of the things they can do to meet the first goal, which is to gain insight across all customers, is use Amazon Redshift and connect Redshift to the S3 bucket with all of the joined and transformed data. So Amazon Redshift is a cloud data warehouse that lets you analyze structured and semi-structured data. And in their architecture, it would look like this. So Redshift can query the data that is in S3. You don't have to export it from S3 and put it into Redshift through a feature called Redshift Spectrum. And Example Corp can use Redshift to perform large-scale analytical queries and use it to gain insight into their data. They also want to build dashboards, and they can do this with Amazon QuickSight, which is our cloud-native business intelligence tool. It's something that a strong testament to QuickSight is kind of the 100,000 strong customer base that spans a number of different industries and use cases. And they're using QuickSight to build dashboards that look like this. So essentially, QuickSight gives you drag and drop code-free interface and a number of analytical functions, and you can build interactive analytics and dashboards based on the data that you pointed at. And then these dashboards can be consumed through your desktop, your browser, tablet, phone, send them as emails, or some customers are actually embedding them directly into their kind of front-end websites. Now, one of the key things that I want to kind of highlight with QuickSight is that a lot of industry trends are showing that customers don't rely on traditional dashboards as the main or only way to analyze their data, because there's a big trend where data consumers want to converse with the data and they want to kind of receive personalized and automated insights that are relevant to them. So one of the things that Example Corp can do with QuickSight is use machine learning to extract more value from this data, again, without them having to write code or hire a machine learning engineer. QuickSight has a feature called Q, and this is a natural language query engine, and it lets the users ask questions about the data in plain English. You can ask questions in a natural language, and the machine learning models will interpret your question, they'll interpret your intent, and they'll generate a visualization that looks like this. You can do forecasting, so you can ask forecasting questions to try to understand what might happen in the future. And you can ask why questions, so you can try and understand the key drivers to changes in data by asking QuickSight, why do you think this, or why is this the case? So now we have our end-to-end data flow, and Example Corp are getting incredible insights into the data that they didn't have before. And they've done all of this without writing a single line of code. I know that Example Corp's scenario, the scenario up front with kind of isolated customer databases is one specific example. I just wanted to wrap things up, show you the art of the possible with a different use case, just to give you kind of a second use case on how Glue can be used. So this is a different use case, different example company dedicated to machine learning. And here you would use Glue to ingest data from all sorts of sources. You would use Glue to transform, clean, and enrich the data, and then extract features. And these would be features used within a machine learning model with DataBrew. And then you could also extract training data with DataBrew and use this as input for your machine learning apps. And so a lot of customers are building this and then using services like Amazon Forecast, which is time series forecasting, Amazon Comprehend, which is natural language processing, SageMaker, which is a fully managed machine learning platform where you can build, train, and deploy your own machine learning models, and Recognition, which is kind of computer vision. It extracts information and insights from your videos and images. And all of the kind of features that have been used as input to this machine learning models can be kind of built and extracted from your data using Glue, again, without writing any code. So my key takeaway from today is if you want a no-code or a low-code ETL solution for data engineering, then I recommend looking into Glue and consider modernizing your ETL tools with AWS Glue. So I know that I've covered a few features, but not all of them. This could easily be kind of a 2 or 3 hour presentation. So I wanted to leave some reference materials here in case you're interested to look into this a bit more. There's some documentation on getting started with Glue. There's a training course that we have and some reference architectures from an analytics standpoint. So I'll leave these up here, but I really hope that you've enjoyed this session, and thank you.
Ralph, actually, thank you for your amazing presentation. And for me, it looks like, let's imagine I'm let's say CTO of organization, or CDO, right? Like trying to build data analytics in my company, and make it effective, right? So, and everything is shown, like for me, as for like person responsible for that, would look like silver bullet, right? So it has everything we need. We can extract data, we can transform it, we can do data wrangling, data profiling, data cataloging. So actually, like the 99% of data engineering like work is here, right? But what is a catch, right? So like, is it the silver bullet or not?
I mean, that's one of you've hit the nail on the head with it being kind of for all personas. So you might remember the slide with the data engineer persona, the scientist, the analyst. These are all different personas, and typically in the industry, you have product built for that persona. So you have a product for data scientists to use. You have tools that the data engineer would use, but there wasn't really anything that was not specific to one of these personas, and so that's really what we tried to do with Glue is create one thing that you can use for your entire pipeline. It's it's serverless, so you don't have to manage things that aren't important, like infrastructure. And again, you only pay for what you use. So it's you're not paying if your job's not running, or if your pipeline's not running, then you're not being charged. So yeah, it really is a great kind of cloud-based ETL solution. We're seeing a lot of customers get a lot of success with it. So it's definitely, obviously I'm biased, but it's definitely a really cool tool.
Yeah, it looks like. But for instance, like if a company runs everything, all the services on AWS, right? Whether there is a case when you wouldn't recommend to use Glue and stick to the traditional data engineering. So what would be the use case, or Glue is like the future of AWS data engineering?
Yeah, so that's an interesting question. So obviously it depends. It's very specific to the use case. You see customers trying to do all sorts of different things, and you have to consider each one individually. For the large majority, it's because it's something that it's serverless and you pay as you go. It means you can try it out. So you don't have to enter into a license to try it out. This is something that you can just go into the console, connect to a data source, build a pipeline, run it once, see if it works, if it fits what you need. If not, then there's no kind of sunk cost that's been wasted on a legacy license that you kind of committed to. It's just you've just paid for that one small test job to run. So a lot of customers we kind of encourage to experiment with it in this way. Just try it out. There's no kind of commitment, and have a go. Yeah.
Yeah. So if it works for you, why not, right?
Exactly. Yeah.
Okay. Cool. And we have some questions from our audience, right? So it means let me show first question from Victoria. And the question is, would using the Glue impact data quality, governance, and security?
Ooh, good question. So it's something that we cover a lot in documentation is about the security of Glue. Encryption in Glue is something that you can enable, which would obviously tackle the security element of that question. Whether it impacts data quality and governance, I can only see how it would be used to kind of help those two things. For governance, it's kind of maybe other tools that exist, like lake formation, which is used to kind of restrict access and provide granular access to your data lake for different users. But in terms of data quality, Glue is something that you can use to improve the data quality. When you're doing these transformations, you're deduplicating data, you're removing things that reduce the quality and making it better.
Okay. And by the way, this is a question from my side. Data Brew, is it the tool based on Trifecta underneath?
I'm not sure. I don't know, to be honest.
Because I never used Data Brew, but I've seen Trifecta, and they have quite similar interface, and that's why I'm asking, right? Maybe
I'm not familiar with Trifecta. It's not actually something I've heard of before. So no, it's a proprietary kind of in-house thing that we've built. Yeah.
All right. So the next question. So can we expect AWS to launch an integrated data analytics platform similar to Microsoft's Fabric with support LLM soon?
Yeah, good, interesting question. So I don't have any visibility into the roadmap for this, so I wouldn't be able to comment on this.
Okay. But any like kind of alternatives or plans or whatever, some work happening?
Honestly, I have no idea. So I'm more kind of customer facing, enabling people to use the tool. I've got no kind of input into the product. I mean, we take a lot of customer feedback, and I do make recommendations to the product team based on this, and that's something that we pride ourselves on. Is a lot of the things that we build is based on what customers want, but that's a completely separate team to me, who've got their own roadmap and plans, and it's not something.
All right. So guys, no deep insights today.
No secrets to spill, unfortunately.
Yeah. Okay. So, and next question, I haven't had a chance to read it yet. So, question from Olga Nazarenka. Thank you for presentation. Could you please, if there is a place for MDM approach for data architecture and how it can be approached? Master data management, I guess it was meant by.
Interesting. Yeah, I will have to check and see if we have an architecture or guidance on this. I'm not particularly sure, but I will have a look. So if you, maybe we can connect offline and I can try and find out and send some resources.
All right. So question about data catalog in the Glue,
sure.
Right? So you mentioned like it can somehow automate the collection of data. So whether it is like fully automated process or you need manually to define the metadata for whatever you put through Glue.
Sure. So it does this discovery through crawlers. So you basically define a crawler, and then you connect it to your data source, and then it goes and tries and discovers the the schema and things. There's a really detailed page on documentation that I'm going to find now, which explains how the crawler runs. It's really interesting. So it's about how they kind of actually interrogate that data store. So I'm going to put that in the chat here, which goes into a lot more detail than I can off the top of my head. But basically, yeah, you would define a crawler, you point it at the data source, and then that goes ahead and interrogates the data and uses various techniques to kind of figure out the metadata.
Right. And maybe question, you work with a lot of clients, right, in data space. And out of all clients you have interacted, how many of those using traditional data processing and how many of those using low-code approach nowadays?
Yeah, that's an interesting question. So I work with a kind of a set of about 25 customers. Not all of them are doing data engineering. A lot of them are kind of doing various different things. We're doing completely architectures for, serverless or video processing. It's not all relevant to data, but of those who are doing kind of this data processing and building out pipelines, I would say the vast majority of them are doing it this way, kind of low code. They tend to be a little bit smaller. They're not enterprise size customers, and they tend to be kind of constrained with the resources that they have and the skills that they can gain. And so this gives them a really nice approach, which allows their existing teams to actually build out these pipelines. So it's for my customer set, which is obviously a very specific, small subset of AWS customers. I can't speak for all of them, but personally, it's very common. Yeah.
All right. So, and in your opinion, the future of data engineering will be in low code very soon, like mostly, right?
I think it varies. It depends a lot. So there are some things where you will need to write code. You might want to do some very advanced, complicated, specific transformations that are unique to you. But I think for the vast majority of use cases that are kind of standard, similar to each other, I think this will make it a lot more easier and straightforward for organizations to do. And I think it's going to really democratize it and allow more organizations who wouldn't be able to do it normally to actually do it and get that insight.
Okay, and taking that into account, what would you recommend to today's data engineers who are working like and writing, let's say, Spark code, like heavy coding, and now we see it's kind of and it's logical, right? So people trying to optimize the effort for organizations for data processing, and we see like new tools rising, which help to make it easier, faster, with less effort, cheaper, and auto scaling is there, right? So everything is included, right? What would you recommend to data engineers, like thinking about their future? Like, what should they pay attention to, like learning in terms of learning, right?
Yeah, that's a good question. So we have lots of customers who are using Glue, who are actually, they're writing the code, or they're using the drag and drop interface to generate the code, but then they're tweaking the code and adding custom things in. So that need for coding is not going to go away. So I think that's still one of the most important things to focus on. That's a other than that, I'm not sure what the next big trend is going to be. I wish I knew.
All right, guys, then relax, you're safe now. At least the nearest couple of years, ChatGPT is not going to write code instead of you. So all right, so I guess we ran through all of our questions. Ralph Richards was our speaker for this hour, and thank you very much. Hopefully you enjoyed this experience as well, because I did enjoy like listening to your presentation, and I guess our audience as well. So thank you very much. Now we have confidence with like, thank you.
Thank you for having me. Really nice to be here. And thank you very much for listening.
Great. Have a nice evening, Ralph, and all the people who joined today. Tomorrow we're going to have the second day of our conference, and I'm giving back the word to Victoria. Ralph, thank you very much again, and see you probably next time.
Thank you.
Bye-bye.
Thank you, Vitaly, and thank you, Ralph. Okay, so right now, I think it's time to say thank you and see you tomorrow, everyone. So first of all, thank you so much for joining this event. I hope you gained a lot of useful insights and valuable knowledge. And please do join tomorrow, because we have much more amazing speakers and topics prepared for you. So, thank you. That's great.
All right. See you tomorrow, and thank you very much, everyone who was listening. Thank you very much to our speakers, and see you tomorrow. Bye-bye.
Thank you once again. Bye.